Rakshiti ma'am, please unmute yourself.
Hello, good afternoon everyone. I, Ms. Prachiti Aire, Assistant Professor at VES College of Pharmacy, welcome you all on the 5th day of National Level Induction Program for Pharm students organized by VES College of Pharmacy. After comprehensive sessions on chemistry and pharmaceutics, now we are moving towards the pharmaceutical analysis, which is an integral part of pharmaceutical process. Any pharmaceutical substance may be raw material, intermediate, finished product, or packaging material. It is required to be analyzed for qualitative and quantitative concerns. Today, we have with us expert and eminent speaker in the field of pharmaceutical analysis. It's great pleasure for me to introduce Dr. Anita Aire, Madam. Dr. Anita Aire is an associate professor from Department of Quality Assurance at VES College of Pharmacy. She has worked in the field of analytical method development and validation pertaining to stability studies, impurity profiling and routine quality control analysis, bioanalytical method development and validation. She has also worked in the application of principles of quality by design in formulation and analytical method development over the past 13 years of her teaching career. She has 25 presentations and 25 publications, including one book on stability indicating assay to her credit. She has received grants from University of Mumbai worth rupees 2,50,000. Dr. Anita Aire has also worked on industrial projects. I'm happy to share that her video regarding analytical method development and validation, which is uploaded on our college YouTube channel, has received 24K views, is really a proof of her lucid explanation. Her today's talk will give us practical aspects of method development by UV visible spectroscopy pertaining to assay and dissolution. Without further delay, I am requesting Dr. Anita Aire Madam to start the session. Thank you.
Thank you, Prachiti, for that lovely introduction. Very good afternoon, everyone. I will just share my screen in a minute and then we start with the presentation. Yes. So today we will be discussing about the practical aspects of method development and validation by UV spectroscopy. The disclaimer, this presentation, the views that are expressed here, they are only my own perspective, the individual perspective. This presentation is intended only for educational purpose. Presentation are redistributed, and the diagrams and images that are included in this presentation, they are only to explain certain concepts. Now viewers, before I enter into the in-depth description of today's talk, I would like to tell you that we will be having an overview of UV visible spectroscopy of the technique without venturing into of this particular technique. So the presentation includes the prerequisites that are required for understanding the concept of practical aspects, applications of UV visible spectroscopy with emphasis on research areas, a brief overview of the instrument and its components, the steps in method development, which include qualitative will be the criteria for selection when you're doing quantitative analysis, that is specifically multi-component analysis. What will be the criteria for selection of validation parameters, the document when you are undertaking UV visible spectrum as an analytical tool, and then the conclusory remarks. Now, as I told you that the presentation specifically emphasizes on understanding what are the practical aspects when you undertake UV visible spectroscopy as a method for your analytical work. So what is expected is you should have knowledge of the basic instrumentation and the principle of working of UV visible spectrophotometer, and you should have a knowledge of the concept of analytical method validation. What are the different parameters, what are the definitions, and what are the different methodologies available. So we will be just discussing on how these validation parameters are applied depending on the application of a particular UV visible spectroscopic method. So to start off with, the UV visible spectroscopy. Now, when you look at UV visible spectroscopy as an analytical tool, this particular technique has broad areas of application. It is not only restricted to pharmacy, it includes application in various areas, forensic sciences, food sciences, chemical sciences, biomedical sciences, physical sciences. We are focusing on specific applications which are related in the pharmaceutical sciences. So here broadly, depending on the area of research, the applications are classified as those that are used for qualitative analysis and those that are used for quantitative analysis. When you talk of qualitative analysis, if you're doing a research in, say, pharmaceutical chemistry, then this technique can be very well used for determining the dissociation constant and hence the pK of a novel chemical entity. You can also apply this method for detection of impurities. So when you are synthesizing a compound and even after purification, you want to know what is the level of purification, you can still apply the method for determining the impurities. Of course, for impurities, you need that are available for characterization of organic compounds. It is used as one of the methods to theoretically predict what will be the absorption maxima, that max of a particular compound. To its qualitative applications. When you talk of quantitative applications, again, depending on the area of research, there are wide number of applications available, whether you are doing a project related to formulation development or you are doing a project related to standardization of a herbal drug, or you're doing a project where you have just extracted some phytoconstituent and you want to quantify it. So in quantitative analysis, broadly, if we see the classic application of UV spectroscopy, it is used to determine with respect to formulation development and uniformity. It is also applicable for dissolution studies wherein you want to find out how much amount of drug is released in a particular time point. Then it is also useful in chemical kinetics. Now, chemical kinetics may be related to determination of shelf life. Chemical kinetics may also be related to if you have to determine the rate of a chemical reaction in terms of the amount of product formed, or even some in vitro study where you want to check whether there is a reduction in the amount of drug with respect to particular time period. So chemical kinetics also employs UV visible spectroscopy, and then it can also be used to determine the molecular weight of a compound. But yes, when you determine molecular weight of a compound by UV, you cannot accurately determine it. For that, you definitely need a sensitive technique like MS. So if you look at the broader aspect of applications of UV visible spectroscopy, whether you are doing a project synthetic chemistry, whether you're doing a project which is related to in vivo or in vitro evaluation of a sample, whether you're doing a project related to purely analytical method development or herbal standardization or extraction, UV visible spectroscopy has all these areas. Why? Because this is one such technique which has a widespread number of applications, and it can be used for both qualitative and quantitative analysis. So that is the USP of this particular technique. So when we venture into the method development aspects of UV visible spectroscopy, you must first understand the overview of instrumentation. Definitely, we will not go into the details of the working principle of the instrument, but just for your understanding, they are available as single beam and as double beam instrument. Single beam instruments are now almost obsolete, and they have been completely replaced by double beam UV visible spectrophotometers, only for the fact that it saves your time of analysis, because in a single beam instrument you have just one sample holder where at a time either you can place a blank or a sample. So definitely the time of analysis is saved. Second advantage of double beam is that because you're simultaneously measuring the reference and the sample, the instrument, the same amount of error is distributed across the blank as well as the sample. So the final reading that you get in terms of absorbance, it represents the reading solely for the sample without any error. So if you look at a brief overview, it consists of a light source, that is your UV, as well as a visible deuterium or halogen lamp, and a visible light source, that is a tungsten lamp. Then there is a monochromator, which can be a prism or a grating. Definitely modern day instruments make use of gratings preferably, because you get wide array of wavelengths that are distributed and specific wavelengths can be filtered out. And then monochromator is followed by a sample holder, wherein there are two sample holders, one for a sample and the other one for your reference cell or reagent blank. Then there is a detector component, and then you get the data. Now, why I am specifically showing you this particular slide is I want to emphasize on the monochromator compartment. One particular aspect when we observe, whenever you venture into a research project where you are making use of UV visible spectroscopy as a technique, as an analytical tool, what you generally do is, if suppose a particular XYZ drug has a reported wavelength of say 240 nanometer, you perform your analytical method, you check for the presence of lambda max, and if suppose you're getting a lambda max of say 238, or if say it is 243, then you suddenly start questioning yourself that whether the drug that you have, whether it is really pure or not. So viewers, you have to remember that monochromator, which is a major component of a UV visible spectrophotometer, it comes with a performance characteristic which is known as the spectral bandwidth. When we say spectral bandwidth, though the definition of a monochromator says that it is a component which isolates out a single wavelength, in practically this does not happen. It can segregate out not a single wavelength, but a broad band of wavelength. And that definition of how much wavelength it can segregate is given by the spectral bandwidth. So every instrument of every make, when you purchase any instrument which is having a very narrow spectral bandwidth, is the one that is preferred. Now, modern age instruments that are available, the ones which are of very good make, like Waters or Thermo Fisher, even such instruments, to give you the illustration, even these instruments, they come with a spectral bandwidth of minimum 3 nanometer. So what does this mean? When you are inputting a value of 250 in your instrument, actually what your sample is experiencing is a wavelength from 247 to 253 nanometer, because the spectral bandwidth limitation of the monochromator is 3 nanometer. So generally all the instruments, they come with a narrow spectral bandwidth in the range of 3 to 5 nanometer. That is why one thing you have to very carefully observe, that in all the compendial procedures that are given for assay or that are given for dissolution, whenever a wavelength of measurement is mentioned, they do not say that you have to measure at this wavelength. They say that you have to measure at about this. So that word about actually covers the spectral bandwidth part. So moving on further, we talked about the instrumental components. Now let us come to the method development aspects. Now when you talk of method development, whether it is qualitative analysis or whether it is quantitative analysis, the first thing in method development that you have to emphasize on is always the choice of solvent or medium for analysis. As you know very well that whenever we are doing UV analysis, the physical nature has to be a liquid, because the light can pass through the molecules and there will be efficient absorption only and only if the sample is in a liquid phase. Of course, in gaseous phase and in solid phase also, the spectras are recorded, but with additional accessories. Normally, the samples that we encounter, they are in a liquid state. Now, if your sample is not in a liquid state, to convert it into a liquid state, you need a suitable solvent. So when you're selecting a solvent, you have to understand certain characteristics with respect to choice of the solvent. The very first important characteristic is the cutoff wavelength. Cutoff wavelength represents that wavelength for a solvent below which it will show absorbance of its own in the UV region, UV visible region, and above which it is transparent in the UV visible region. Then next important thing is polarity. Polarity and the pH of the medium point later. First, we will be discussing on the cutoff wavelengths. So there are a series of different solvents available for which the cutoff wavelengths are mentioned. As you can see in the given table, water, methanol, ethanol, these are some of the solvents which are really having a very low cutoff. Water is having a cutoff of 191. So methanol is having 203. Ethanol is having 204. So these solvents are really the solvents of choice when it comes to UV method development. However, if suppose your drug is having a nature in such a way that it does not easily go in these solvents, specifically if it is more non-polar, then you may have to go for solvents like chloroform, you may have to go for solvents like benzene or carbon tetrachloride. But the limitation is these solvents do have a high cutoff. That is why when you are choosing a solvent, you have to know what is the cutoff wavelength of that particular solvent, so that if suppose the lambda max of your drug is XYZ, at that particular wavelength, the solvent does not show its own absorbance. So the solvent that you select should be transparent in the UV range. Now let us talk of the polarity. Why polarity of a solvent is important? Now when you have a choice between and an organic solvent, say ethanol or methanol, when you have to make a choice between water or methanol or ethanol, so logically, you may go for choosing water because it is easily available. It's a universal solvent. It's cost effective. But you have to understand that water, since it is a highly polar solvent, it has a chance of exhibiting dipole interactions in the sample molecules. And because of the dipole interactions, there is a change in the electronic transitions of the sample components, and eventually whatever spectra is generated or the absorbance value is generated for the sample, that is obscured. Hence, if you have to choose between water and an organic solvent, always the preference has to be given for an organic solvent, because in organic solvent the dipole interactions are very minimal or they are not present at all. Then next is the pH of the medium. Now, when you talk of a medium, generally the word medium is encountered when you do not have one pure solvent to dissolve your solute, and hence you have to go for an acidic medium or a basic medium. You have to adjust the pH of your medium so that your solute dissolves and you will be able to record the UV spectra. So generally, we encounter medium estimation or determination of dissociation constant for novel chemical entities, where you are absolutely not having any idea with respect to the polarity or the solubility practically. We also encounter a medium whenever you are undertaking dissolution studies. So that time, the pH of your medium definitely influences the UV absorbance spectra. So you have to ideally choose a medium in which your solute is maximum in its ionized form. If your solute is in its maximum ionized form, whatever wavelength and absorbance it will show, it will be at its peak level. However, yes.
Sorry to interrupt you in between. Yeah, now slide is moving. Yes. Earlier it was not moving.
Hello.
Yeah, now it is moving, ma'am. Earlier slide was not moving.
Okay. So pH of the medium definitely influences the ionization state of your solute. And because your ionization state of the solute is affected, that will decide the nature of the absorption spectra. So more the ionized state of a solute, better will be your spectra in terms of maximum absorbance and in terms of maximum wavelength. So more the ionization of your solute, better will be the spectra. Hence, pH of the medium should be always decided in such a way that your solute molecule should remain in its ionized form. So we have already medium based on the cutoff wavelength of the solvent. The next important parameter when it comes to method development is dilution scheme. Remember that dilution scheme is something which is really important whenever you are undertaking qualitative or quantitative analysis. So we will first discuss for qualitative analysis. Generally, whenever you do qualitative analysis for UV visible spectroscopy, your only aim is either to identify what will be the lambda max for your solute, or your aim may be either to determine some particular constant. So you are restricting yourself only to identification of the lambda max. So for such kind of studies, whenever you have to dilute the sample, you just have to consider the limitations of Beer-Lambert's law. One of the major limitations of Beer-Lambert's law is not applicable at higher concentrations. So when you say high, means how high? So a limit is given in terms of absorbance, that if the absorbance of a solute in a solution goes beyond 1, then that is considered as a high concentration in terms of obeying the Beer-Lambert law. Likewise, on the lower side, if you're getting an absorbance value which is less than 0.01, then that is also not considered, because any absorbance value below 0.01 is considered to be equal to noise. Okay, so hence, whenever you are doing qualitative analysis, you should dilute your sample in such a way that your absorbance should lie in the range of 0.1 to 1, preferably. Now let us talk about quantitative analysis. Now before we move into quantitative analysis, there is another aspect that you have to consider, that is your lambda max. How do I select, or how do I choose which lambda max is the best for my compound? Now one common myth amongst research students is that every drug should have only one lambda max, but that is not the case. Whether a drug will have 1 lambda max or 2 lambda max or 3 lambda max, that solely depends on the number of chromophores that are present in a molecule. So a compound, a molecule or a drug can have more than 1 lambda max depending on the number of chromophores that are present in it. Now when you have to choose a lambda max for your measurements, you have to choose the best one. So what is the best that is defined? If you just go by the definition of absorption maxima or lambda max, it is that wavelength at which the absorbance of your compound is maximum. So you simply look at the spectra and choose the wavelength at which the absorbance shown is maximum. But that does not always have to be the case. So you have to decide the lambda max based on what is your end application. Now, if suppose you are, just to give you an example, if you are doing a formulation development, and in your formulation development, you are going to incorporate such kind of excipients which are lipid based, which are of lipoidal nature, or which are surfactants, then definitely these lipids and surfactants, they do contain chromophore of their own, and hence they interfere in the spectrum of your drug up to 250 nanometer. So if you are having a drug which is showing 1 lambda max at around 230, and that is the highest, lambda max at say around 280, which is not that high, but it is significant enough that you can measure it. So definitely you have to choose a lambda max which is 280. Why? Because you know that further when you are going to make a formula contain such excipients which will interfere at the lower wavelengths, and hence you have to choose a wavelength which is preferably on the higher side. However, if you know that your end application is not going to encounter a medium or solvent which is going to interfere with your analysis, then definitely you can go for which is showing maximum absorbance. Now we come to the quantitative analysis part and coming back to the discussion of dilution scheme. Now, whenever you talk of quantitative analysis and UV visible spectroscopy, there are different methods by which this quantitative analysis can be done. Methods are either standard, you measure its absorbance, sample, measure its absorbance, cross multiply and find out what is the concentration of your sample. This method is called as a single point standardization method. Instead of one standard, you may take two standards and then again apply the method. But normally what is commonly observed with respect to UV visible spectroscopy is when you go for single or double point standardization, every time when you are changing the protocol of your method, you have to go for a new standard. And hence, the method of choice for quantitative analysis is use of external standard, that is the calibration plot method. Because when you apply this method, instead of taking one or two standards, you are taking a series of standard dilutions. You establish the linearity of your method across a wider range, and then you can very significantly use this method for quantitative purposes. So when you talk of dilution scheme and its application to quantitative analysis, you have to understand that it goes hand in hand with the calibration process, because calibration is the technique that is for quantitative analysis. Now, which type of applications make use of calibration? When you talk of formulation development, calibration is made use of in dissolution studies, in content uniformity, then of course in assay. When you talk of impurity profiling with respect to synthesis of novel chemical entities, there also called calibration plot is useful. It is also useful in kinetic studies. So we will see what is the overall brief process of calibration experiment. It starts with planning the experiment. Now, when you talk of calibration plot, you have to select a series of different standard dilutions of known concentration. So, two factors are very important over here. How are you choosing the levels of your concentration? Are they really equally spread apart? And what is the range of that concentration level that you are testing? Hand with your end application. So just to give you a simple example, when you're doing quantitative analysis of say an assay method, or if suppose you're doing quantitative analysis of a dissolution method, a general myth that is followed is researchers or students, they generate a calibration plot randomly assuming that the Beer-Lambert's law should be followed in the range of 0.01 to 1, and then the same calibration plot is applied across for dissolution, for assay, for content uniformity, and any other type of study wherein you need to find the amount or concentration of the drug. But this is a very wrong protocol that is followed. The ideal way to approach or plan your calibration experiment depends on your end application. So how it starts? If suppose you are doing a dissolution study, let us of a paracetamol tablet wherein the label claim is 500 mg. As per your dissolution protocol, the volume of the medium is supposed to be 900 ml. Then you have to go by the reverse way. Before deciding the calibration levels, the standards, the range and the dilution, you first take a drug of paracetamol which is equivalent to 500 mg, dissolve it in 900 ml of your medium and derive a certain dilution and then find out what is its absorbance. If suppose you're getting an absorbance of say 0.5 after doing a certain dilution scheme, then you have to prepare your calibration standards in the same way. Means there in your final dissolution, if it is expected that 500 mg of your drug will be going in a medium which is having a volume of approximately 900 ml, when you are preparing the stock solution for your calibration standard, your stock solution sample should also be provided a similar environment. So it's not necessary that you take 500 mg of drug and dissolve it in say 1000 ml of a solvent, because that will be a waste of your solvent as well. But you can always scale down your quantities and see to it that the dilution pattern remains the same. Why this is important? Because whenever you are correlating the data of calibration to quantify the presence of your drug, not only the nature of the matrix, but also the volume of the matrix or the medium matters. If you are taking lower volume just to save your time or just to save your cost, then definitely the errors will be reflected in your dissolution profile. And then you may blame your formulation for not meeting the desired standards of the dissolution, and then you may play around with the formulation. But before doing that, always this is one of the important things, that whenever you are planning a calibration experiment for dissolution, you have to go by the reverse method. You have to take the drug, dissolve it in a medium, and then reach a certain dilution and find out its absorbance. And then for your calibration studies, you select a suitable concentration which will also give you the same absorbance. So in summary, you have to actually match the absorbance of the sample that is expected with the standard. When you match that, then your standard that you are selecting, that becomes your target concentration or test concentration. Then you have to choose the other levels below and above that target concentrations as per the recommendations of the ICH guidelines and as well as the USP guidelines. Okay. The next important thing is making measurements. Making measurements is nothing but, once you have decided your dilution scheme for the calibration standards and the range is decided, you prepare the solutions as per the protocol and you make the necessary measurements. Then you plot the graphs and then you carry out statistical analysis of the data. You evaluate those results for linearity, and then you use the calibration function or the equation that is generated to estimate the values, that is the concentration or amount of your test sample. Another thing which we as researchers fail to do is we do not estimate what is the uncertainty associated with the values obtained in the test sample. This uncertainty, just to give you an example, if suppose you are taking a series of measurements of concentration and you are plotting a graph using an Excel sheet, you will observe that practically not all your points fall on the arbitrary straight line that is expected. One or two points are such that are deviating to a very huge extent from the best line of fit. So in practicality, you have to actually consider those points at outliers if they are significantly deviating from your regression line. So that uncertainty has to be considered, and then you have some new ranges wherein the uncertainty is not too high. So to give you an example of how do you select the range, as I had mentioned you earlier, that one practice that researchers follow is they take the same calibration curve and use it throughout all the experiments. However, as per the recommendations of the ICH guidelines on analytical method validation as well as US FDA recommendations, your range of calibration curve is decided by the application of your method. For example, if you are doing assay, then the range of your calibration curve should be between 80 to 120% of test concentration. Now, what is this test concentration? As we discussed, that if you have to do an assay, expecting 100% release. So total amount of your drug as per the label claim, that has to give you 100% assay. So you have to prepare a concentration of your tablet, make a suitable dilution, measure its absorbance, and accordingly follow the same scheme to prepare the calibration standards and match the absorbances of both your sample and the test. So that becomes your test or target concentration. So for your calibration range, the concentration that you choose should be between 80 to 120% of this test concentration. Likewise, when you're doing dissolution studies will depend on your dosage form. You may do dissolution studies for immediate release or for sustained release dosage form. So depending on your requirement, what is the final acceptance criteria for your dissolution? Say sometimes if it is a sustained release tablet, your expectation could be within 1 hour, there should be a release of 20%. And then after 8 hours, there should be a release of at least 80% or 90%. So you have to broaden your calibration range, that you take the test concentration and you start from 20% of the test concentration up to 100% of the test concentration. Likewise, when you're doing content uniformity, the recommendations are you start with 70% of test concentration up to 130%. Likewise, when you're doing impurity profiling, testing impurities in a novel chemical entity, you have to start from the reporting level, that is as low as 0.1%, and go up to a maximum of 120% of the test concentration. So always when you plan the experiment for calibration studies, you have to first select the range, and only within the decided range, you have to take a minimum of 5 different concentrations, perform the calibration experiment, do the regression analysis, generate the equation, and then only apply that equation for getting your results in terms of amount or concentration. If, however, you apply a common calibration plot for generating the amount or concentration of your drug, either in a formulation or assay, definitely you will get an error in your results, and then your first inclination will be towards some problem with the formulation development. So always you have to be very careful when you're choosing the range of your calibration experiment. The next important point, when we discuss of quantitative analysis, we talked about the calibration experiments. Another important point to discuss is for multi-component analysis. You will see that nowadays there are many formulations which are available wherein more than one drug are present together because of the synergistic effect or to lesser the side effects. So there are many different combinations of anti-tubercular, anti-malarial or antibacterial drugs, or say for that matter diuretics with antihypertensives. Many combinations are available. Now such combinations, they are important for their pharmacological action, but definitely when it comes to the analysis of such type of formulations, that becomes a challenge for the analytical chemist. Likewise, if you are doing a synthesis of a novel chemical entity and you are interested to find out or report the lambda max of that novel chemical entity, one challenge that you may come across is if that novel chemical entity is containing a process related impurity whose concentration or amount is significant. When we say significant, say around 1 or 2%, then that also becomes a challenge for the analytical chemist, because you have to remove the interference which is coming from that impurity. So when you talk of multi-component analysis, depending on the nature of the other component, your multi-component analysis method varies. So many of the times researchers, they are either not aware of this multi-component analysis methods, or the easiest way out is they go for directly choosing HPLC and completely avoiding UV visible spectroscopy. But mind well that there are many research publications and literature available which shows a wide application of multi-component analysis method, wherein just by using UV visible spectroscopy, you can nullify the interference which is coming from significant impurities or the interference that is coming from some other drugs that may be present in your particular sample. So depending on the nature of component, either that component can be an active component. For example, a formulation which contains more than one. When you have such kind of a scenario, you can always use any one of the known multi-component analysis method and you can go about doing your analysis. So there are many methods like simultaneous equation, Q absorbance method, solvent extraction method, geometric correction method. And you can apply any one of those methods and do your analysis. However, if your compound of interference is a non-active, like if it is an impurity, if you're doing some herbal analysis, some assay or say qualitative analysis of some phyto, the interfering compound can be a matrix component. That time you have to adopt a suitable strategy to nullify the interference that is coming from that non-active substance. So to illustrate this, I have taken some case studies which were performed in our lab, and I will be explaining you the examples of how you nullify interference with the help of these case studies. So the first case study is you are having a formulation and you are intended to apply the UV method for dissolution studies of that formulation. But when you are applying the method for dissolution studies, you have to first check whether there is an interference from the medium or not. In this case, the medium selected was pH 1.2 buffer with a surfactant because that was the requirement of the dissolution protocol. So it represents the spectra for the medium, whereas the black line that represents the spectra of the drug in the dissolution medium. Now, this is a very idealistic situation. Here you will see the medium is not at all interfering at the lambda max of the drug. So if that kind of scenario exists where your medium does not interfere at all, then you do not have to go for any multi-component analysis method. You can simply apply single component analysis, wherein you record absorbance, then you fit that absorbance either in your calibration curve or in your Beer-Lambert's equation, and you find out the concentration or amount. A thing to note over here is, how do you decide that what is significant interference and what is not? So mind well that when we are talking with respect to UV visible spectroscopy, the range of absorbance that is considered linear in terms of Beer-Lambert's law starts from 0.01 to 1. So a value of 0.01 absorbance represents 1% of the total absorbance. Generally, for UV visible spectrophotometers, it is considered that any absorbance value which is below 1% is as good as noise. So that is why whenever you are talking about significance, if your interfering compound is showing you an absorbance which is less than 0.01, then you can just ignore it and follow single component analysis method and proceed with your analysis. One way of nullifying the interference of the medium is you may go for dilutions. To such diluted sample, the interference that is coming from the medium is very negligible, that is less than 0.01. But that does not happen always, as you can see here. In this particular case study, you can see there are three spectras. The first spectra that is shown by a black line is the spectra for the drug in the medium. The second spectra that you can see, it is shown by the red line. This is for the placebo formulation. And the third one, that is the blue spectra, it is for the spectra of the formulation itself. So in all these three spectras, the concentration of the drug in case of the drug in medium and the drug in formulation was kept to be same, that is 10 microgram per ml. Still, you will see that when you are recording the spectra of the blank medium, that is a red line, that blank medium is showing an interference at the lambda max of a drug, and the interference is very, very significantly high. When you come across such kind of a spectra, though you keep the formulation blank, a sample holder, and you record the sample by keeping it in the sample compartment, you will never end up getting the accurate reading for your absorbance. Hence, always remember that whenever you are applying UV visible spectroscopy for any application, what is important is you have to always first record the spectra of your medium, whether it can be a dissolution medium or the medium which you are using for the assay, or a medium which may be just a solvent or a mixture of solvents. You have to always record the spectra of that blank medium or solvent, and then you have to compare or overlay that spectra with the sample spectra or the drug in that medium. So you will get an idea how much is the extent of interference coming from that medium. So as you can see in this particular graph, when there is such kind of a situation where the formulation blank itself is interfering to a very huge extent, here you definitely have to go for a multi-component analysis method. Or the second choice is you may go for a chromatographic method or an LC-MS method. First, we will look at how you can decide whether you can go for a multi-component analysis method or you have to go for other sensitive analytical techniques. So this is another example where you can see interference. This is a case study for a microemulsion, wherein you will see that the placebo microemulsion, the spectra for that placebo microemulsion, it is showing a constant absorbance shown by the black line through the entire UV range. Whereas when the different concentrations of the formulation containing different amount of drug, when they were plotted, all the absorbances, they were very much low on the absorbance scale, and also there was no significant sharp hump in terms of lambda max that was observed, because when you take lipids as a part of your excipient, say you're preparing a liposome or you're preparing a microemulsion or you're preparing solid lipid nanoparticles, because of the presence of high amount of lipids and surfactants, they contribute a lot to the chromophoric component of the molecule, and hence they show huge amount of interference. So when such type of a graph is encountered where the interference from your excipient is constant throughout the UV range, the visible range. There you can go for a multi-component analysis method, which is known. So what is done in derivative spectroscopic method is, you don't separation of the sample. Derivative spectroscopy is just the mathematical transformation of your spectra. So you simply have to select different concentrations of your drug in the formulation and also take the derivative spectra of your excipient or the formulation. In derivative spectroscopy, different derivatives of the spectra are generated: first order, second order, third order, fourth order, and so on. As you go high in terms of your derivative spectra, the interference coming from the constant, that is your excipients or the formulation reagents, that is nullified and that becomes equal to 0, because a fundamental principle of derivatives is that whenever you take a derivative of a constant, it is always 0. So this way you can nullify the interference that is coming from the excipients or the formulation blank. So as you can see, this particular graph represents the first order derivative spectra of the same plot that we had seen here. So this is a 0 order spectra, that is absorbance versus wavelength. Whereas this graph is a plot of difference in absorbance versus wavelength, and on the y-axis it is wavelength. So when you are taking a first order derivative, you will see that the interference that is coming from the excipients, that is nullified and it is almost on the 0 line. Whereas the lambda, that is the amplitude of your absorbance for different concentrations, that has increased. And this way you can choose a selected wavelength and measure the amplitude of absorbance at that wavelength for your formulation, apply the formula of Beer-Lambert's equation and find out what is the concentration. So this is one of the simplest method wherein you don't have to enter into the hurdles of developing a chromatographic method first for your drug, then for your formulation, doing the validation, and then actually doing the assay or dissolution for your lipid-based formulation. So derivative spectroscopy is one such technique which is very commonly utilized for recording the dissolution and assay results for a lipid-based formulation. There is another example. This case study was also done in our lab, where there is a combination of atorvastatin and the estimable this drug combination. Now you will come across such kind of research work where you are having 2 or more components in your mixture and you intend to identify the concentration of components without physically separating them. This is also encountered in the extraction of phytoconstituents or herbal analysis, where your sample contains an array of different compounds, but not more than 4, and you have to quantify each one of them without physically separating them. So whenever you encounter such type of components, as you can see here, the spectra of both the drugs ezetimibe and atorvastatin, you will see that throughout the entire range from 200 to about 350, both the drugs are showing a very overlapping spectra. So when such kind of spectras are obtained, you can never apply the conventional simultaneous equation method or absorbance ratio method, or for that matter solvent extraction method. You cannot apply any of the easily available multi-component analysis methods for determining the concentration or amount of these drugs. So here the method that you can choose is, you can go for dual wavelength. What is done in dual wavelength? For every drug, you choose 2 different wavelengths. These wavelengths need not be the lambda max of those individual drugs, but they have to be 2 such wavelengths where the difference in absorbance is significant. Such 2 wavelengths you have to select, and then you have to take different concentrations of that particular drug. You have to observe that as the concentration of your drug is increasing, the difference in the absorbance at the 2 wavelengths has to increase. So that linearity has to be followed. Likewise, you also take the other drug, you select 2 where the difference in absorbance is significant, and with increase in concentration, the difference is also linearly increasing. And this method you can very easily apply either for assay or for dissolution or for content for determining the amount or concentration of that drug. The only thing that you have to do is, every time, instead of doing your measurement at 1 wavelength, you have to do the measurement of at 2 wavelengths, and that can be done at one go using the modern softwares that are available. So this is another very good example to show you that without venturing into high-end sensitive analytical techniques, how you can very effectively make use of UV visible spectroscopy simply by changing the mathematical transformation of your measurements. So this is another important way by which you can do the analysis of components where the spectra of the components are too much overlapping. Now next, we discussed about the method development aspects. Now we come to the validation parameters. As I had told you earlier, that we will not be venturing into the definitions of the different validation parameters and the procedures, because you are very well aware of all those techniques. So we will be directly coming to the checklist. Now, one common mistake that is made by researchers whenever they go for validation of methods, whether it is a UV method or chromatographic method, is they directly follow the checklist, that there are 8 or 9 different parameters, so we just have to perform all those parameters. However, you have to understand that ICH-Q2 guidelines on analytical method validation, they have recommended that whenever you undertake validation studies for any analytical method, whether it is spectroscopic or chromatographic or any other kind of analytical method, the validation characteristics or parameters that you will study will depend on what is the end application. So a table is given as per the ICH guidelines, and I have directly picked up the table from the ICH guidelines. As per that table, the different analytical methods, they are categorized into 3 types. Category 1 represents identification, means when your method is just qualitative analysis, where you are intending just to identify lambda max, or just to identify what could be the predicted lambda max for a compound when you know the theoretical one, just identify, or it could be just identification of some impurity. Second category is testing of impurities, that is quantitative analysis of impurities or limit test. And the third category is where you are interested in finding out the content or amount of a drug or a molecule in a sample. So that is applicable to assay, that is applicable to content uniformity, potency, or dissolution. So what the guidelines say is that whenever you are doing only a qualitative analytical method, there you need not perform all the validation characteristics. You have to just perform specificity. So in the table, you will see some plus and minus symbols. Minus represents you don't have to do that particular study, plus represents you have to do. So for qualitative analysis, the only parameter that has to be studied is specificity. That is, at your wavelength maxima, there should not be any interference coming from the solvent or the media. However, when you are doing impurity testing, when you are doing quantitative analysis by UV, where you are testing the presence of an impurity by judging the change in the absorbance value, there you have to undertake accuracy, you have to do the precision, both interday and intraday, that is repeatability and intermediate precision. You have to do specificity, you have to do limit of quantitation, you have to do linearity, and you have to do range. Likewise, when we move to the third category, that is when you are applying your analytical method for assay or dissolution, or say for content uniformity, you have to accept detection limit and quantitation limit. Remember that whenever you're doing assay or dissolution, you are not expecting presence of impurities, because that contradicts the hypothesis of your method. When you say assay, your expectation is you should get 100% of the label claim. When you are saying dissolution, the release should be as per the criteria of your dosage form, whether it's immediate release or controlled release. So when you do assay and dissolution, you definitely do not expect presence of impurities. Because you do not expect presence of impurities, there is no need to determine the limit of detection and limit of quantitation for assay and dissolution methods. However, I do understand that there are some research papers available wherein they just follow the validation parameters as a checklist. But as a good practice, good laboratory practice, you should always first study the table before you undertake the validation study for any of your end applications. So that was about validation. Now we come to the last aspect of UV method development, documentation. Now, when you talk of a student, that is a graduate student, and when you're transforming into a research candidate or a research scholar, documentation is something that you really have to work on. So when you talk of a UV method development, you may say that, What is difficult in it? What do I have to document? It is just I'm preparing a sample. Either I'm taking an absorbance reading, noting it in my notebook, or I'm taking a spectra and then that spectra. But remember that documentation becomes an important aspect of every component of your research project. So whenever you are doing UV studies, whether qualitative or quantitative, you have to follow a pattern in which you have to maintain your documents. So when you talk of qualitative analysis, it first starts with the method protocol. What is this method protocol? This method protocol will include what is the aim and objective of your study, what is the procedure that you have actually followed, means how you chose the medium, what is the choice of your medium, what is the range in which you are doing the study, whether it is UV range or whether it is a visible range, how you have decided on instrument parameters or whether they are set by default, what are the details of the instrument, and then you actually record your UV visible spectrum for the qualitative application, and then you tabulate the data in terms of the wavelength maxima that you have found out and the absorbances that you have reported. So you have to always follow a good documenting your results. When it comes to quantitative analysis, as I told you, quantitative analysis goes hand in hand with calibration studies, because when we talk about UV spectroscopy, calibration curves are the one, that is the method which is generally adopted for quantitative analysis by UV. So more or less the discussion will be always in favor of calibration method. So again, it starts with your method protocol, that is aim, objective, your materials used, the procedure that you have followed. Then the UV visible spectrum, though in quantitative analysis spectrum important because you are just measuring the absorbances, but still you have to record the spectrum, because as we had seen in the earlier slide, that based on the spectrum you come to know whether there is an interference from your medium or not. Hence a record of that spectra, whether interference is there or not, is very much important, and that also helps for your validation studies as a part of specificity data. Then you have to provide the data as per the prescribed format. Now what is this format? This is just a representative example of how your format should look. Definitely you can modify this format depending on your requirements, but more or less the parameters that you need to document as a part of your UV visible analysis study, they are mentioned over here. So you have to mention the name of your lab, the name of the analyst who is doing the study, the date of analyst, the wavelength, the path length that is used for measurement. Mind well that there are many softwares available wherein this data can be automatically generated. When you are feeding the method parameters, you can generate the data in the form of an Excel sheet. But if that is not available, you can always generate your data in the form of an Excel sheet. Then you have to look at the calibration results, because we are talking of emphasis will be on calibration studies. So you have to put the target concentrations that you have selected, actual concentrations that you have got after substituting in the equation, and what are the resulting absorbances for the same. What is the correlation coefficient for your calibration studies? What is the and after substituting the absorbance of your sample in the calibration equation, what is the answer that you got in terms of concentration? Calibration concentration data that can vary depending on your end application. If suppose it is assay, then you may represent it in this same form, that absorbance, what is the resulting concentration and how much is the percent recovery or the assay content. If it is dissolution, you may find out how much is the percent release in terms of based on the dose of your drug, and that you may tabulate. So this particular data for concentration of your sample will vary from your end application. Now your document should also include additional comments like what is the instrument that is used, what is the temperature at which analysis is performed, because though we perform UV visible spectroscopy at ambient temperature, that is room temperature, for some kind of samples it may be necessary to maintain a cold environment. So for such type of samples specifically, the temperature becomes important. What is the order of analysis, whether you did run of your standard followed by sample, again bracketing with the standard, all that information has to be given in your report. And then lastly, it should be followed by the calibration plot that is generated and the plot of residuals. Now, for some of you, you must be wondering that why this plot of residuals is given as part of your calibration data. So mind well that US FDA guidelines on analytical method validation, they say that whenever you are doing linearity, the establishment of linearity of a particular data should never be judged solely on the basis of correlation coefficient. You should have additional statistical evidence to prove that your method is linear. So one of the very common methods by which statistically you can prove that your method is linear is by plot of residuals. Now, what is this plot of residuals? Here, the plot of residuals represents a plot of, on y-axis, it is the predicted concentration minus the actual concentration, that difference versus the actual concentration. So ideally, if your method is really linear, then the difference or the error that is encountered in your method should be evenly distributed on both lines of the residual plot, that is on the in the first quadrant as well as the second quadrant. So there should be an equal distribution of the residual points. However, if residual points are having a scatter, or if all the points are on one side of the plot or on the other side, it means your method is non-linear. So a method is said to be statistically linear when there is an equal scatter of your residuals, and those residuals are found out from this table. That is your target concentration, expected, and the actual concentration or predicted ones, and you take a difference between the two. And that is how you plot the residuals and establish the linearity. So definitely, as a good laboratory practice, whenever you are doing calibration studies, please do not judge the linearity of your method solely on the basis of correlation coefficient, that is R square value. Additionally, you have to give additional statistical evidence either in the form of plot of residuals, or you may also go for performing an ANOVA or a t-test with respect to the calibration equation, and you may find out that whether significantly close to zero or not. Another important thing to note over here is whenever you are plotting a calibration plot for any quantitative analysis methods, you should never allow your line to pass through zero. Why? Because as per the recommendations of the guidelines, it is expected that one of your concentrations in the calibration curve has to be zero sample. Zero sample means just your blank without the presence of analyte. So because of the error coming from the instrument in the form of background noise, or because of some errors on your part as personal error or reagent error or some random error, even at zero concentration, always some signal output is given in the form of absorbance, and that you cannot simply neglect it by allowing the line to pass through zero. So whenever you are constructing a calibration curve, your line should never pass through the zero. It should always have a y-intercept. However, once the y-intercept is generated, you can always statistically prove that whether the y-intercept value is significantly equal to performing a t-test, and then you can follow the regression line, and then you can go about doing your predictions. So that is another important care that you should take when you are plotting the calibration curve. Now, to conclude, since we have discussed about the practical aspects of UV method development, I will be just giving my conclusory remarks in terms of what you have to do and what you should not do whenever you are doing UV analysis whenever you are doing analysis by UV visible spectroscopy. So the most important do's to remember is you should always follow a standard protocol. If there is a method reported in pharmacopoeia or any compendial method or any standard method is available for a particular UV analysis of a drug, always follow that method. However, if a method is not available, definitely you will have to develop your own method. But if you are developing your own method, means if you are deciding the solvent, if you are deciding the dilution scheme, if you are deciding the calibration range, then always you have to validate your method before you apply it to your end application, that is your assay or dissolution or impurity profiling. That is necessary. Another thing is you should be always careful with your dilutions. As I had mentioned that when you do qualitative analysis, you must simply obey Beer-Lambert's law, that is your dilutions should be such that absorbance fall in the range of 0.01 to 1. However, when you are doing quantitative analysis, you must first identify what is your target concentration. That target concentration can be identified based on your end application. How your sample is going to behave in your end application, likewise you have to treat your standard in the calibration curve. Follow the same dilution scheme, and then definitely the results that you will get will truly represent the results for your sample. Otherwise, always you will end up getting errors in your result, and the blame will go on the end application part. What you should not do whenever you are doing UV visible spectroscopy or using it is you should never blindly follow any research article. See, because for every research article that is present in a journal, the researchers, they have applied that method or protocol considering that end application, their end application. That may include choice of a lambda max. For instance, for a particular drug, the reported lambda maxes can be 270 and 320. The researchers, for because of their purpose, they might have used 320. So you should not also blindly follow 320. If there is a scope that you can make use of 270 nanometer as your wavelength of measurement, definitely go for it. You have to decide what will be the wavelength for your method. You have to decide what will be the dilution scheme. You have to decide which calibration range suits your method. You have to establish the linearity in the selected calibration range and only follow that. So do not blindly follow any research paper. You have to always reach a conclusion based on the holistic approach. Means if you are not ending up getting the results as were expected, the very first question should be on the analysis part. You have to start questioning starting from the instrument, whether the instrument is calibrated, what was the last time when it was calibrated, whether the reagents that I am using are of analytical grade, whether the cuvettes that I am using are really made of quartz, because mind you, that makes a difference. If you make use of cuvettes that are made of glass will always absorb the wavelengths in the UV range, whereas quartz as a material does not. So the type of cuvette that you choose, whether you're making use of clean cuvettes, all these small things, they really matter a lot. Then it comes to your method, whether you're following the right dilution, whether your calculations are correct. And then you go on towards the other side, that is the application side, that something must be right on the application. So always you have to adopt a holistic approach whenever you are developing an analytical method. So you have to consider from all aspects. One thing you can do as a good practice is you may tell your lab partner to follow the same procedure, because human errors are also not inevitable. You cannot control them. And then if that analyst is also getting similar results like you, then you may nullify out that factor and you may go for finding the root cause with respect to some other factor. So always maintain a holistic approach when you are doing analytical method development, not just for UV but for any method. And then lastly, yes, whatever materials, whatever reagents that you are using, they should be of standard quality, because without that you really cannot end up getting your proper accurate results as per the expectations. So with this, I would just like to say a quote over here, that many a times as researchers, we really forget our science, our scientific knowledge that we have studied, because we narrow down our vision only to one particular aspect or part of a research that we are doing. So hence, your scientific knowledge is very important, and that is the key to success of every experiment. So you should always follow and remember your science whenever you are applying it to any part of your research study. So thank you, and the session is now open for questions.
Thank you so much, Anita ma'am. We should really take a breath now after this exhaustive, at the same time, the comprehensive session. Thanks once again for giving insights right from instrumentation, applications to all critical steps in method development of UV visible spectroscopy along with the case studies. Now we'll move on towards question and answer session. Yeah, we'll take first question from Saili Darvi. In case of multi-component analysis, which method is most appropriate?
So, Siley, it is again a good question. So, whenever you are doing multi-component analysis, the first thing that you have to look at is you have to look at the nature of your component. If the other component is an active, then definitely the first thing that you will do is you have to observe the spectra of the sample in terms of individual components as well as in a mixture. Based on the spectra that you get in a mixture, you can decide which method you have to apply. For example, if your other component is also an active and it is also showing a lambda max of its own, if the lambda max of the other component is dissimilar from the first component by at least 10 nanometer, then straight away you can go for applying simultaneous equation as a method of your analysis, or Q absorbance method for that method. However, if you are interfering substance or other component, it is an active, but the spectra is very much overlapping with the first component, then you can go for dual wavelength method. That is, you select two wavelengths for a drug which are not necessarily the lambda maxes, any two wavelengths at which linearity is obeyed, and then you go about doing the analysis. So when you do multi-component analysis, always the criteria for multi-component analysis has to be set, and accordingly you decide the method. Okay.
Shall we take next question?
Yes.
Yes. Okay. The next question is from Priya Gupta. In case of herbal drugs, how should we analyze the sample?
So again, that will depend on how many constituents you are expecting in the herbal formulation. Ideally, UV spectroscopy, if at all you have to apply it for herbal drugs, it can be very well applied if the number of constituents, the phytoconstituents expected, they are not beyond 4. If the number exceeds beyond 4, definitely you have to go for a more sensitive technique like HPLC or nowadays HPTLC. If the number of components are limited to 3 or 4, then you can definitely go for any one of the multi-component analysis methods that are available.
Okay.
Yes.
Yeah, the next question is from Kajal Bajaj. She is asking, can we use multi-component analysis method for the essential oils?
Definitely, you can use multi-component analysis. If your essential oil is an active or if it is a non-active, you can definitely use. For this, you have to first record the spectra of your essential oil alone. Then you have to record the spectra of essential oil in the medium that it is expected to be present. You have to also record a spectra of your essential oil in the presence of other components if you are expecting as a part of your formulation or a final application. And then based on that, you have to see how much is the interference. Means if you are really interested in quantifying the essential oil, then derivative spectroscopy is one of the best methods. However, if you want your essential oil is not an active, it is just present as a part of the formulation, then you can nullify its interference by other multi-component analysis methods. So yes, definitely you can use.
Okay, ma'am. Yeah, the next question is from Bhavisha Vadvani. What is the bioanalytical method validation for which sample it is used?
Okay, so bioanalytical method is altogether a different concept, and bioanalytical method for this dedicated guidelines are available as per US FDA, as per EMA. Even ICH is going to come up with dedicated guidelines on bioanalysis. They were not available till date, but that is altogether a different concept, and your routine principles of analytical method validation does not apply there, because there your sample or active will be in the presence of a biological matrix. So depending on the nature of biological matrix, accordingly you have to decide the validation parameters. But UV spectroscopy is not at all the method for bioanalysis. For bioanalysis, either you have to go for a chromatographic or hyphenated method as a choice.
Okay. The next question is from Shilpa Gajbie. In case of a solid lipid nanoparticles containing lipid content along with phytomolecules and essential oil, which analytical tool should be used to perform dissolution profile?
Okay, so Shilpa, again, if this is about lipid molecules, you depending on your end application, okay, it is dissolution. So the very first thing that you can do is for your phytoconstituent, and then for the formulation which contains the phytoconstituent, and for the medium, you can record UV spectra. You can first start with UV spectroscopy because that is the simplest and possible method that is available. Then depending on the nature of interference, maximum number of times it is observed that the lipids or the surfactants that are present in any formulation, they show a constant absorbance throughout the UV range because the number of chromophoric groups are many, and hence their absorbance throughout the UV range is constant. So derivative spectroscopy by UV is always a method of choice whenever you have such kind of samples. If that does not work, then you can definitely go for chromatographic methods.
Okay, ma'am. The next question is again from Priya Gupta. How to analyze a herbal drug sample with several constituents using UV visible, and can we use already reported method because we have to develop own method for novelty ground?
So many a times what happens is, if the purpose of analytical method is to only specifically quantify one of the constituents that is present in a mixture, then definitely you can very well do that by making use of single component analysis. However, as I told you earlier, that if the number of constituents are more, and if the number of constituents are more than 4, then in such cases you have to go for chromatographic methods, because UV, the mathematical calculations when it comes to multi-component analysis, they are very easily applied if the number of components are restricted to 2 or 3. But if the number increases, the mathematical complications increases, and hence you have to go for an alternative approach. But definitely, if amongst the different constituents your interest is only to quantify one or two phytoconstituents, you can do so by UV spectroscopy.
Okay, now we'll take the last question of the session. That is from Siddhi Bhosle. How can we analyze the herbal preparation by UV spectroscopy?
So
Again, that is
Siddhi,
the
it
repetition.
yes, it again starts with the method development starts with selecting the solvent or the medium for your herbal constituent. So it starts with the solubility studies. You have to select a solvent which is having a very low UV cutoff. Then it starts with selecting the concentration. So if you are interested in qualitative analysis, then you may do a suitable dilution in the selected medium and get an absorbance which is in the range of 0.01 to 1. However, if then it is quantitative analysis, again depending on whether you are going to do a formulation out of that herbal constituent, and then what are the demands with respect to the formulation. Accordingly, you have to decide the method development aspects.
Okay, that was the last question, ma'am. Thank you
Okay.
once again, Anita madam, and I'm really happy that you are with us so that we can ask you questions at any step, at any time.
Yeah, I would just
Thank you,
like to
Anita
add over
madam.
here that the case studies that I had shown, these are those case studies which had come out of the research problems in our own lab. So the purpose why I showed these case studies to all of you is, see, UV visible spectroscopy as a technique is really undermined nowadays, especially considering the fact that many chromatographic instruments are available. But mind well that method development with chromatography is very, very challenging. Now, there are some things which are really achievable with UV visible spectroscopy as a technique alone. And this technique is sensitive enough as long as you are working in the microgram range. So that is why these case studies I had purposely shown you to emphasize that yes, UV visible spectroscopy can be widely used whether you are dealing with one component or more than one component. So thank you, Prachiti, for your kind words.
Thanks a lot, ma'am. Dear participants, now we'll take a break for 10 to 15 minutes and we'll start with the next session sharp by 3:30. The next session will be taken by Ms. Sneha Singh along with her colleagues. Will be live from Ancrom Lab where you can see the demonstration of HPTLC. So kindly resume by 3:30. Thank you so much.
Good afternoon, one and all. My name is Rashmi Vani. Allow me to welcome all of you in today's second session of Day 5 of Induction Program for Pharm students organized by VES College of Pharmacy. Right now, I am associated with VESCO as an assistant professor in the Department of Pharmaceutical Chemistry. Now, let me introduce Ms. Sneha Singh. Starting her career as a lab chemist in Arctic surfing chemicals for a short span of 9 months, she gained further experience in EnviroCare labs for a couple of years. At present, she is working as an application chemist for HPTLC in Ancrom Enterprises India Private Limited. Her expertise mainly lies in HPTLC system applications and their troubleshooting. She has traveled extensively across the length and breadth of India to share her knowledge for various customers in pharma, herbal and cosmetic sector. Today, she will be delivering a talk on standardization of herbal drugs. We welcome you, Sneha ma'am, for this session, and over to you, ma'am.
Thank you, ma'am. Thank you for such a nice introduction. So, good afternoon, all. Myself, Sneha Singh from Enchrome India Private. Welcomes you all for this HPTLC webinar being hosted by Enchrome HPTLC specialist in cooperation with Vivekanand Education Society, College of Pharmacy, Chembur, Mumbai. In this session, we will cover many aspects of HPTLC, including the technique, instrumentation, application, and its regulatory aspects. My lab and Chrome lab colleagues are also present in the session to answer your questions. Hope you all have a knowledgeable session. So I will start from the acknowledgement slide of VESCOP and Chrome. Here you can see our three links of linked accounts, social media accounts like LinkedIn, Facebook, and YouTube. You can be with us in these accounts. Next is the ma'am. Can you hear me properly?
Yes,
Hello.
ma'am, you are audible, perfectly audible.
Yes, perfectly audible. Okay, thank you. So today's topic is about model regulatory HPTLC techniques, its instrumentation and application in standardization of herbal drug by me, that is Neha Singh. I'm the application specialist. So we not only give the instrument but also train the system, train to the system. So pre-training, pre-HPTLC training is there at Enchrome. You can email us at hptlc@enchrome.in, and our WhatsApp and calling number is as follows. We have trained all the government officials, government lab, pharma companies, postgraduate students, and also teachers. The training is there for 1, 2, or 5 days at Enchrome Mumbai lab. Dates are decided by mutual convenience. Certificates are issued after training to all the participants, and till from since 1994 till 5,000 scientists has been trained by us. We have also signed certain MOUs with prestigious universities and institutions. So this is the new look of our new Enchrome HPTLC's application center, which is there at Mulund. It has a capacity of 20 trainees at once, where all training takes place. It has all ChemAg instruments included in it. There are 14 analysts, which includes 2 PhDs, and this year 2 more are going to introduce as a PhD students. We have separate set of instrument for hands-on training purpose. We have signed certain MOUs with university and for research institution. We also have a program called PhD Earn and Learn scheme. So this is our YouTube and Chrome YouTube channel. Here you get a detailed information about both the softwares, training videos of all the softwares, which is WinCat and VisionCat. Also, you can search under the name of Enchrome on YouTube. It is free for all, for students, for professor, for their teaching courses. So now we will start our topic, that is with the definition of chromatograph. What is chromatogram? We have a mixture which we need to separate, and By separation, we get three conclusions. First is for identification of that separation, what it is, and then quantifying it, how many of it is present in your standard is present in your sample, and then go for micro preparation, that is for new inoculation of your new isolation product. So these three are the main aim of a chromatographic technique. So after identification, we can go for comparison in UV, visible, and fluorescence range. And then after that, we can go for the absolute, that is the hyphenation technique known as TLC-MS technique, IR technique, and NAR technique. Now, this is the TLC which college students perform. Here you can see spotting is done, and afterwards through the mobile phase it is gone beyond the spotting technique, and then afterwards we get certain patterns, separation pattern of standard. This is standard, and these are the samples. So here you can see that the spot is separated from other bands, and also see the presence, but you cannot confirm it because it is just a spotting technique and it is manual technique. Whereas this is the HPTLC technique, analysis technique. Here you can see different five type of samples, which can be standards, is separated in different bands, and you can compare it with other samples given below on the same plate as well as on different plate also. So this is the technique which we are going for, that is the HPTLC technique, which is an hyphenation technique of TLC, and which is nowadays very much in need. So further I will go for the TLC technique which we do on 20 by 20 plate, and HPTLC technique which we do on 20 by 10 plate. The both gives you same resolution, same power of resolution to your standards, to your samples. And we can save a lot by going to HPTLC 20 by 10 plates, because we are going for 60 mm of its developing distance, whereas in TLC 20 by 10 plate we are going for 135 mm, which takes lot of time, whereas 60 mm it takes half of its time, half of its mobile phase. So this technique is miniaturization technique, which goes with your less solvent, system. Less time is needed and more samples are done in your 20 by 10 plate than in your 20 by 20 plate. So we should always go for this HPTLC 20 by 10 plate. So here is a comparison of TLC and HPTLC. First, they are both are same principle, that is planar chromatography. Second, the primary focus of TLC is it is simple, it is low cost. Whereas HPTLC, the primary focus is for reproducibility, as it is a band technique and it is not done manually, it is done by your PC control and software. So reproducible result and separation power should be good for HPTLC. So the process is for TLC, it is very flexible with no rule or with some rules. Whereas in HPTLC, it is highly standardized methodology and it has optimization parameters. Next, TLC, for method, only few parameters are defined. Whereas in HPTLC, well-defined parameters are there and also validated parameters are there. So TLC, it is very flexible, very high. Flexibility is very high for TLC. Whereas in HPTLC, there are none to validated methods and high between methods. Next, the target which we focus on TLC is very rapid and preliminary results we get from the TLC methods. Whereas in HPTLC, we get reliable analytical results because it is software generated, and we get proof results of the presence of your standard or sample, the quantification result, the quantitative results. All results are very proof. And the data structure for TLC, it is very simple, and photography is also very simple, chromatography is also very simple. Whereas in HPTLC, we get traceable digital images scanning quantified by SST, and also it has a good laboratory manufacturing practices compliance as well as good laboratory practices compliant reporting system. In TLC, you can only do samples and standard by referring on side by side on the same plate. But in HPTLC, you can compare from other plates also. Also, you can compare from different plates also. Also, you can compare from different year also. How, I will tell you in next few slides. Instrumentation for TLC, it is very none to simple instruments, whereas in HPTLC, it is very simple to sophisticated. Cost for TLC, it is very low, but for HPTLC also, it is very low as compared to other techniques like HPLC or GC. Next, HPTLC, why we can go for HPTLC nowadays, because it is very simple and it is very reliable and it is very fast technique. Why it is simple? Because very few steps are needed for them. Sample preparation is also very simple and the quantification methods are also very simple. Also, it is very fast. Yes, we get results in 1.5 hours. There is another technique, we get only one result, that is sample or standard results, one sample or one standard result in 1.5 hours. Here in HPTLC, you can get 15 to 20 sample results in 1.5 hours. So it is very fast technique. So no contamination of chromatogram. As you know, every time we need a new TLC plate for quantification or for identification. So no contamination of your chromatogram is there. Whereas in other technique, there is very contamination of your chromatogram, like columns. You have to give washings to them. But here there is no need of that. Very simple and fast as I had told you. 1.5 hour are required for 15 to 20 samples. Whereas for other techniques, it requires 1.5 hour for only 2 or 3 samples can be done in that time. It is low cost and maintenance. Yes, it is very low because only 20 ml of your mobile phase is required. Only 40 ml of your mobile phase is required for simple identification test for one method. So it is very low. Double confirmation results visible and also for printers. Yes, you can get this. Large feedback is also there because you can do your testing in UV region, that is of 190 to 400. Then on fluorescence region, a special light is there, that is 366 nanometer for your fluorescent substances. Then you can get spectra from 190 to 900 nanometer. Also after derivatization also you can get a result. So such a large results can be done in this HPTLC. So the practice of HPTLC is first of every technique is sample preparation. Then we can go for sample application technique through the applicator module. Then the third is chromatographic development through the development module. Visualization through the visualizer, and scanning can be done through scanner. Then after scanning, if you don't get any results in UV region, and if the sample is present in after derivatization, then you can go for derivatization module and again go for scanning and photo documentation. So these are the simple practice of your HPTLC, and different modules are used for different practice of your HPTLC. Different modules are used for different steps of your HPTLC technique. So in few slides, we will get to know all this module. Now the applicability of this technique is for the research lab is, first is the modular hardware. For other such instruments where only one person can do one time, here you can work different modules on different person. Likewise, you can do 5 to 6 samples or 5 to 6 projects can be done on the same one HPTLC instrument. So it has a modular where multiple analysts can work at the same time, and which is easy to upgrade. It has data-oriented software. Each analyst can keep a track of its work on its name. So if my name is there, so what am I doing will be saved by my name. And if another analyst is doing on his name, so his work can be searched by his name. Like this easy searchability, easy password of every analyst, and easy to generate report is done by this HPTLC technique. Minimum use of solvent, I have already told you that 15 sample can be done per plate, and for that 15 sample only 30 ml of your solvent is used. So you can just imagine how cheaper and how cost saving it is. So minimum use of solvents. So fourth point is disposable SPTLC plate. I had already told you that the instrument, in this instrument you need every time the new plates, like you need for other instrument you need columns and all, but here only new plates are needed, which is easily accessible and which is easily disposable. So disposable SPTLC plates are used, and solid enchrome support since 1978. We enchrome doesn't gives you support, doesn't gives you instrument, but also gives you solid laboratory support as well as the service support also. Now, what are the regulatory acceptance of HPTLC? We have seen about the hard software, but now we will see about the regulatory acceptance, which is there for HPTLC technique. So it is officially in USB chapter 203. In this chapter, you can see all these parameters set by USB. So it is under the chapter name HPTLC for identification of material of botanical origin, which also accompany the chapter of 1064. It was official from August to 2015. It is also official in European Pharmacopoeia, which is harmonized with USB chapter. It will be also you can see in Indian Pharmacopoeia also, and also in WHO guidelines for herbal medicines. So these are the four regulatory acceptance of HPTLC. This is the USB parameter which I was talking about. The chapter deals with all the parameters of HPTLC should be used while doing your samples. Likewise, if you have a plate layout of 20 by 10 plates, so what should be the distance from the first rack side to the first rack? Then what should be the distance between the tracks, between the 15 tracks, distance between the tracks? And what should be the distance of one of your band? So these all things are there in this chapter. Also, it gives a comparison study of spot versus band, why we should use bands in case of spot. So these all comparisons are there in this chapter. Also, they have given specification why 8 mm of your band length is required for better resolution. Why this 8 mm is only there you should go for. So these all things are there in this USB chapter. It also deals with the distance traveled by the solvent level. So it is 6 mm here. So it gives you better resolution, better separation of your samples. So likewise, why we should use only 6 mm or only 7 mm for our sample. So it gives you all the results. Also, it gives you a comparison between the chamber configuration, that is TTC and HDC, horizontal development, and your TTC chamber to interrupt chamber, and also gives you about the relative humidity, why we should go for 33% humidity, why we should not go for 47% humidity. All these are there in this USB chapter 203. So this is the complete software uh, system software of HPTLC, that is the Vision CAD software, which controls all the device, that is sample applicator, chromatographic device, scanner, documentation, post chromatographic device, and scanner. This is the complete system of HPTLC. You can see applicator through which you apply your sample onto their plate. Then go for development, through which you add solvent and your plate is there and it gets developed. after then you can go for photo documentation or and scanner, or if you required go for your derivatization technique, then go for scanner and photo documentation, and then other hyphenation techniques. So this is the whole complete HPTLC system. The visualizer takes photo of different of in different light, and scanners through which we get the chromatogram, and this is the TLC-MS interface through which we get the illusion of your sample, and it goes to MS technique. So this is the hyphenation technique. This all is the complete HPTLC system. Now, this is the new product launched by Chemac, that is HPTLC Pro. It is fully designed for QC unit because they have specified methods. So after specified method, they only have to give you the plates, and it can be done. Like is we have different modules in current HPTLC system, but here we will not have different modules. We have a one full 5 modules set one side, and only the plate will be entered from one side, and the plate will be taken out after derivatization. After all this module has been done, 5 modules, it will be taken out. So this is for the QC department, but it is the new technique, so that's why we are showing it. Here you can see all the 5 modules attached to one another. So you just have to put your plate through the first module, that is the applicator. Then it will automatically apply your sample. Then go for development. Then go for derivatization, visual scanning, and after MS. So like this, it will automatically go. You don't have to take your plate, take to the next module like you do now. It is fully automated system, and it is for QC department. This is the working of the 2 modules, that is the applicator and development, which is there in Switzerland and which is also there in our Mumbai lab. So you can see they are working. So these are the 2 modules which are released till now. More 3 modules will be released in next 3 years. So you can see how fully automatic the system is. And by releasing 5 modules, that means you can done 4 to 5 different methods at the same time in different modules. So this is kind of what the automation is. Now, what are the compliance highlight of this system? So first is the US FDA 21 CFR rule, which is very important for the pharma companies, which tells you about who has started your system at what time. So it keeps a track. So this is what is a US FDA 21 CFR rule 11 compliant tells you about that, and which our system fully is compliant with it. It also has a good laboratory practices and good manufacturing practices compliance. IQOQ of every modules can be done. All data stores are in encryptions and password protected database. A digital sign can be done up to 5 levels, and access can be given to up to 7 levels. Then full audit trials can be done from system as well as for users and for instrument also. It has also a built-in backup tool with scheduling system which tells you about at what time, at what day you can schedule your backup tool, which is very important for your pharma companies. Then this is the user right management. This is how the user right management looks about. It gives you the login ID, the full name, the position of that manager or DM, and also gives you the these are the tick marks which gives you about the user management, which gives you use of create and edit analysis, where you can edit your analysis, you can create analysis. It tells that you have your this user management system in your uh, analysis. Then this is the user management. This is once again the user management, and which gives you password and security manager. It gives you at what password length it should be, allows you to change your password after 90 days. So these are the certain important highlights of our software system. It also gives you regulatory settings, which gives you who can, means the auditor can check, what all the auditor can check, and what all you can check in your system, and who all can be given the authority of checking. So these are the regulatory settings which can be done through this software. These are the system audit trials. This is how it looks like, at what time, at what date you have entered your system, at what changes you have done. All these messages are done. It also gives you pre-analysis audit trial also. The same thing, at what time, what changes you have done, why you have done. This is the backup tool which I was talking about. Scheduling, here you can see start date and time, and also you can set this. Also you can set your file at which you can give your settings. Then you can also select the date, also the number of backup to be kept, 10, 15, depending upon you. So these all things are very important for your pharma companies. Now we can come to HPTLC sample preparation technique. So here we are talking about herbal. Of other technique also it is very simple. Of other sample also it is very simple. We have a powdered sample. We dissolve it of 100 mg per ml in methanol. Then go for sonication to dissolve the substances. Then we go for centrifugation, and then the supernatant is taken for analysis. It is very quick and very low cost, a very simple technique. It takes only half an hour for preparation of herbal samples. For other technique, it depends upon your API, how it is. You can do the same thing, but if the API has a rugged nature, so you can go for other technique. But the results are very similar to this technique. These are the two modules of sample application. You can use this one for sample application as well as this one. Both modules can be used. This is the semi-automated one, Venomat 5, and this is the fully automated one, that is ATS 4. Just have to keep your samples. The syringe take its sample, apply it on plate, and then gives the sample ready for development. Whereas here you have to every time take your syringe out, you have to rinse it, you have to take your sample at what ml, and then again keep it in this turret. So this both the modules are PC controlled, spot, band, and rectangular can be sprayed. Precisely they spray. It has good laboratory practices compliance. It transfers data for quantification. So both are similar, but one is semi-automated one and other is automated one. Now here is a video, you can see how it works. Uh, Hello, ma'am. Am I audible properly? Hello. Hello.
Yes, ma'am. Please go ahead.
Am I audible properly?
Yes, you are audible. Perfectly audible.
Okay, because my Ancrom colleague are saying I'm not audible. Okay,
Now
so
you are
I will
audible.
continue.
Yes. Yes,
Okay.
yes, definitely.
So these are the two techniques which are called as sample application technique. This is the contact process one. We have studied all the solvent, how it takes place when we do contact process as well as when we do spray on technique. So you should be amazed that it is the spray on technique, not the contact application technique, which is done by the applicator. So these are the sample application technique which takes place through this applicator. This is the quantitative one. We have to apply your standard and sample and then go check for the quantification, how much it is present in your sample. Then this is the in situ cleanup technique which are done for fatty matters. We apply it in the middle. Apply the samples in the middle of your plate. Then cut. Then go for the development of that plate to the with the polar solvent, and then cut it from 120 degree and again rotate it to 180 degree and again develop the mobile phase. Develop the sample in the suitable mobile phase so that the fatty matters is removed from the polar system and we get only the sample analysis for the mobile phase to be carried out. So this is the in situ cleanup technique which can be done on plate. This is next is the micro preparation isolation technique. This is for the isolation of your fraction, suitable fraction. So what we do in this, we apply 190 mm of your band, full band to the 20 by 20 plate. Then we develop it in the suitable mobile phase. Then we cut that developed portion, which we go for isolation, and then dissolve it in the suitable methanol or suitable solvent, and go for isolation technique to higher to TLC-MS or something or NMR technique, which is to be done. Then next is superimposition technique, which is done for internal standard spiking or for the uh, uh, presence of their sample, for finding out the presence of your sample. So this superimposition is done by applying standard and sample on the same band, and then developing it on the same bands, and going for quantification of that. So this is the superimposition technique, which is done for recovery purpose, which is done for spiking purpose. So these four technique can be done through this module, application module. This is the micro preparative technique which I was telling about. We develop the plate after applying 190 mm of your band. We develop the plate. Then, for example, this is the sample to be isolated. So we cut this, then we dissolve it in the suitable solvent, and then go for the isolation. And after filtration, we go for the isolation technique. This is this chromatographic development module. These three modules are used. That is the gradient evaluation chamber, AMD2, ADC2, that is automated development chamber, and this is a twin trough which majorly we use for college purpose. So in there is a certain infatuations of TLC and HPTLC. So for that, this slide is there. For 10 by 10 play TTC chamber, we use 10 ml of your mobile phase, whereas for TLC, when we use flat bottom, if we are using 5 by 10 plate, also we use 45 ml of our mobile phase, which is very wrong. So if you have a twin trough chamber and you have 10 by 10 chamber, 10 ml of your mobile phase is used. And if you have 20 by 10, then 20 ml of your mobile phase is used. And if you have 20 by 20, then 35 ml of your mobile phase is used. Also, we should take some key points for preparing our mobile phase for TTC chamber. That first point is there is some extra volume of mobile phase should always be prepared. That if you are going for 10 ml of your mobile phase, then go for 15 ml. Prepare it extra. Prepare 50 ml of 15 ml of a mobile phase, so that 10 ml you can use, and remaining 5 ml you can discard. But it can be used whenever required. So like this type. Then always measure your volumes of different solvent by using pipette. Different solvent is there. In college life we do from one pipette only, but for industry purpose we require different pipette for different solvents. Then always use the measuring cylinder for taking out the fixed volume for TTC chamber, and always weigh accuracy of your mobile phase for the development to get your reproducible result. So if you are measuring 20 ml for one time, and if you are measuring 25 or 22 ml, then the reproducible will not be there for your result. So that's why always weigh accurately. So this is the main this thing of twin trough chamber. Here we add a chamber filter paper. Then we add your mobile phase on one side to the filter paper. Then we tilt it to 45 degree, and then wait for 20 minutes for chamber saturation. So here what we do, we add our mobile phase on one drop. Then we tilt it to 45 degree, so that it can get divided into equal amount to both the trough, and then afterwards we wait for chamber saturation. Chamber saturation is from from this filter paper also, from sideways also, from downwards also, and from everywhere the chamber saturation is done. So this is the main thing. And also you can see this trough of angle 45 degree. So for flat bottom chamber, what we do, we always keep our plate tilted at 45 degree, but the 45 degree for every one it is different. But when we use this twin trough chamber, the 45 degree is same because of this trough. So we always rest our plate in this trough, and the 45 degree angle is remained fixed for everyone. So that's why the reproducibility of your results is there. So that's why we use twin trough chamber, which is specially designed by CAMAC. Next, this is automated chromatographic development, ADC2, which we call. This is there. The specialty of this is to control your humidity. If you want 33% of humidity, so there is a salt called NgCl2. You have to prepare the saturated salt for that 33% of humidity. Then if you want certain API to be tested at 47% of your humidity, so KCl salt is there. So that salt is prepared and kept in that chamber so that it gives 47% of humidity. Likewise, it has a formula of controlled humidity for your plate. So for controlled humidity system, this module is used, which is known as ADC2, which is also known as automated chromatographic development chamber. So this is fully automated software control. It controls humidity. It has layer equilibrium. It also has solvent front migration distance is monitored, and plate is automatically removed after development. Also automatic drying is there. Also one more point is there. It has cold drying system, which is very important for your API, because some APIs are heat resistant. So after when we dry the plate with hair dryer, which has 55 degree of your heating, so what happens? It gets degraded on plate. So for that purpose, this cold air drying is used in this system. So here is a video of how it's worked. So here you can see this is the chamber which is filled with saturated solution and which gives you the controlled humidity. So next is the gradient development. In this gradient development, what you can do, you can change your composition. There are 5 solvent bottles are given. So in every step, every 2 mm of your plate, you can change the composition of that 5 solvents, and you can give n number of steps. So this gradient can be done from polar to mid-polar, then non-polar solvent. So here is an example. So what we have done, we have taken 3 solvent, red, green, and blue, and it gives us this results. The 1 and 2 is not resolved fully after this composition of red, blue, and blue and red, green, and blue, whereas 3 is resolved in this system. Then what we have done, we have changed the composition of red, green, and blue. Then you can see that 1 and 2 is not that bit resolved, but 3 is still resolved. Then what we have done, we have removed this blue color solvent from our composition system, and then you can see 1, 2, and 3 is resolved, fully resolved in this solvent system of red and green. So like this type of system we can prepare through this AMD2. Now you have another called visualizer module called visualizer, wherein you can take the photo in 3 lights, that is 366 mercury lamp, 254 UV region, and R white, that is for the tungsten lamp, which is for your R white region, that is 400 to 900 nanometers. So this visualizer photo documentation gives you good laboratory practices compliance. It has IQOQ, and it goes with 21 CFR Rule 11 also. So this type of comparison can be done. Here is an example of a curcuma sample which is done years. 30 to 35 batch is tested of curcuma in the mobile phase toluene acetic acid 4:1, and the sample prepared is 0.1 gram, that is 100 mg per ml sample. It is sonicated for 10 minutes centrifuge as I have shown you, and 35 batch of curcuma samples are prepared, and you can compare it through this visualizer and our WinCat software technique. So you can compare it to 54 light, 366 light. After derivatization also you can compare it in R white 366. So this type of fast comparison can be done of one or more plates through this visualizer and VisionCat technique. This is now another module called scanner, which is the heart of HPTLC, from through which you get the chromatogram, through which you get the quantification line. So this is the schematic of your scanner. So this is the plate. After giving enter, after doing the scanning, you get this chromatogram output in the signal. There is a lamp through which it is passed to the monochromator. There are 3 lamps here situated. For fluorescent substances, it has mercury lamp. For R white region, 254, it has deuterium lamp, and for R white region, it has tungsten. Sorry, for UV region, it has deuterium lamp, and for R white region, it has tungsten lamp. So like this, 3 lamps are situated in your scanner. So once we select the lamp light goes to monochromator, then it gets reflected to mirror to the plate, and then detect to the photomultiplier, and then the output is received through which we get the chromatogram. So here you can see there is a 1, 2, 3, 4 bands which is converted to the output. So here the TLC plate is moved under the light beam, and the reflected light is detected, and the signal is transferred to the output. So this type of schematic is done in the scanner. Now scanner, what all scanner can we do? So fully automatic scan and spectra can be done. It has ultra fast scanning and spectra. It has beam alignment check. It has good laboratory practices. It covers your UV, visible, and fluorescence range, which I have told you. and it covers full 190 to 900 nanometer range. It works on diffuse reflectance. We can go for spectra for identification and also for purity check of your sample. So this is the absorption spectra. For example, take these three substances which gives you same RF, but it will give you different absorption spectra of these three substances. So like this type of spectra can be used for identification of your substances. It can also give you the purity check, which is done for the low RF, for the start RF, mid RF, and for the end RF. So like this type of purity check also can be done. Also the identification check can also be done through this scanner. This example of THC, tetrahydrocannabinol, which gives you absorption at 210 nanometers. So here in 254 light, you can see there the presence of band cannot be seen, but after scanning at 210, it shows you the presence through the chromatogram, and it will show the quantification of both THCA and THC, both at 210 and at 285 nanometers. These are the chromatogram quantification line. So a scanner can do quantification, can do external standard technique. It can be done UV visible range. It can go for fluorescence range also. We can go for spectra. We can go for multi-wavelength scanning also. So now there is an other technique called post-chromatographic derivatization technique. It is done for specificity. It is also done for ultra high sensitivity. Also for additional information. Likewise, I said if certain substances does not give you information in UV visible range, so UV range, so you can go for chromatographic technique. That is nothing but attachment of your chromatogram to a reagent. Different reagents have different attachment of your compound, and that reagent, what they do, they after heating of the plate, they become visible to our eye. So like this type of chromatogram group means colored substance. So it gives you visual presence on your plate, and through that we get visual confirmation. So these are the different derivatization reagent and different primary mobile phase, which can be used for different class of compounds. For herbal substances, like for alkaloids, you have drag and drop reagent, you have this three mobile phase. It can be shown presence if orange bands are observed in R white region. So like this type of mobile phases are there, like this type of class of compounds are there. There are 15 class of compounds. I have taken example of alkaloids. That there is flavonoids also, isoflavonoids, steroids, anthraquinone, glycols, tannins, essential oils, triterpenoids, coumarin, bitter principles, saccharides, phenolic compounds. Like this type of 15 to 20 class of compounds can be done for herbal samples. So this is the device through which you can do derivatization. This is the immersion device, wherein 200 ml of your reagent is required. The plate is attached to this stand, and then by pressing enter, it goes down and come up and dip, and then we have to heat it in the plate heater. Now you have this new device for derivatization technique, wherein only 2 ml of your reagent is used for 20 by 10 plate, and 4 ml of your reagent is used for 20 by 20 plate. It works on piezoelectric spray and it gives you fully reproducible results. So here is a video. Please look into it, how it works. Okay, there are four different nozzles which gives you different. This is the CAMAG recommend settings which is provided for the different nozzle. So from here the 2 ml of your sample reagent is loaded, and there are 6 levels. Like this type of nozzles are created. So this is the methanol for extraction of the vapors. So you can see the reproducibility of the samples. So there is other module called TLC-MS interface. After this, all the technique, this is the hyphenation technique called TLC-MS interface technique, which is used for confirmation, characterization of single MS, which is used for chemical synthesis, phytopharma, for pharma R&D, cross-checking, and for food substances. It is also used for identification of known from unknown or unknown from known methods. This is the basic principles of TLC-MS coupling. Here you go for the solvent, which is attached to an HPLC pump, and its in outlet goes to TLC-MS inlet, and TLC-MS outlet goes to the MS technique or MS coupling technique. You can say ESICMS or LCMS or GCMS, whichever technique you need for hyphenation. And the plate is attached here. So what the solvent do? The pump gives you the solvent, and the solvent is sprayed, and with the solvent, the through the plate, the sample of interest is eluted, and with the solvent it goes to MS. Here it has a frit which resist your silica, which is when eluted from your plate. So the feed, what it does, it only takes forward the solvent with and the samples which is dissolved in the solvent, and the feed, what it do, it resists the silica very. So the MS life is restored. So this type of TLC MS coupling is also there. Here you see the schematic. So the best argument for HPTLC MS is we have a method of choice. Separation of complex material like plant material, lipids material, or material which has higher sugar content, which can not be separated in our TLC method. It can be separated through HPTLC-MS. The flexibility of multi-detection, you can detect in LCMS, you can go for GCMS, you can go for ESIC, you can go for any other MS you want. Then the identification of herbal medicine and botanical dietary supplements, which are very complex in nature, can be detected by this MS technique. No solvent limitation and no carryover is there. Direct and cost-effective MS independent analysis is there, and effect directive analysis can also be done. It, it, if you don't have any MS technique, then offline coupling can also be done. That you can collect your sample in the vials and later on go for MS technique. This is example of tadalafil, which is there in the sample. So through which we have taken out, and this is the quantification results of tadalafil. Then we go for MS technique. This is the signal shown 390 by the standard tadalafil standard, and You can see the same signal 390 in your sample mode also, in both positive mode also and in negative mode also. You can see the same signal shown. So this means that the Tadara field sample is present in your sample, and we can do TLC-MS by this technique. So this was the poster, which was a joint venture of Shimanju and Enchrome, which was presented at ASMS conference at USA in 2015 June. So this was a poster about which was about of characterization and isolation of quinones in Tectena grandis Lenin leaves. So it gives a you can find this paper on net as well as in our site also. So here they have studied detailed study of how what all unknown substances are present and how they find out through LC-MS, MS technique and HPTLC or TLC-MS compliance. So now we go for HPTLC fingerprinting, which is very important for HPTLC system. So here HPTLC is nothing but the fingerprint. We get different fingerprint for different plants. So through the fingerprint, we can compare the geographical nature. We can compare their the different toxicity or the adulteration can be compared through the fingerprint technique. So it is an electronic image of visual HPTLC chromatogram. It represents your samples. It includes the application front position, and it also consists of the sequence of colored zoom, and also has a multiple image detection mode also, wherein you can take your photo in 254 366. Also after derivatization also you can take your photo. So this type of huge images and detection modes are generated. Here is an example of 14 fingerprinting results and comparison. So 14 fingerprinting are taken in a plate of different geographical region of certain species and different species plant. So they are compared through these three standards. They are compared. So you can clearly see that they are giving these three standards. Here is a comparison of fingerprinting of Angelica gigas. 29 species of different Angelica plants are given, and they are distinguished. Uh, different species of Piper longa, Piper nigrum, cubica. So there are different species. You can find it this method in HPTLC association method. Then you have HPT mobile face optimization. So how you can optimize your mobile face if you have first started the R&D from toluene ethyl acetate. Here is an example. So first we have started the mobile face with toluene ethyl acetate 9:1. Then you can see it in first image before derivatization, after derivatization image also it is given. So here you can see that it is giving us a better resolution, but not that much. The down one is not that much better. So what we do, we have added certain amount of acid, 0.1% of acid to it. So you can see in the next image that it is giving, so the lower one is gone, and you can see here the upper is, it is getting separated. So we have added, so we have increased the quantity of acetic acid. So here you can see in third image that the pattern is not that similar to the second one, and also the lower one it is getting very low. So what we have changed, we have changed the acid and also the concentration of the acid. So here you can see the blur image of all the bands. So like this type of R&D is done before fixing of your mobile face. Here is a literature, some literature of it on HPTLC. First one is the HPTLC association. Here you can find 1,000 different herbal drugs methods. Also, you have a CAMAG application fields, different application fields and application modes on it. There are some books also. This book is done for ICRAC, who is the person quality control in charge of, or we can say the higher person of CAMAC. Then you have quality standard Indian medicinal plants 1 to 16 volume is there. Plant drug analysis. I have shown you certain class of compounds uh, pattern. So here you can find in this book that plant drug biovaginal. Then there is a book of HPTLC for Prem Jaiswal, food analysis book. Then you have a HPTLC PD SETI book, which is the basic, which tells you about the basic of HPTLC. So there are many reference books you can find out. Now there is one more module in HPTLC, that is bioluminizer or bioactive detector. So what this detector do? We can check the toxicity level of our sample with the bacteria such as Vivo fisheries bacteria. What we can do, we can just derivatize it through this bioluminizer. We can keep it in, just like we keep it in incubator, we can keep it in this machine, and through you can see these black bands. So here the arbor-weaver pressure is so sensitive that if the toxicity is higher, so it dies, and it produces the black color substances. So these are the substances which are toxic. So that's why if the arbor fishery dies, it gives black color and it gives presence of your toxic samples. Whereas if you can see in some part of the samples, it doesn't get black color. So that means that the substances is not that much toxic. So this is example of a wastewater. So bioluminescer application can be done for toxicity profiling of wastewater, for pesticide residue, for food beverages, dietary supplement screening, for toxic residues in soil, for selective detection of biological activities in natural products, etc. Now we can talk about bioassay. Bioassay are of four types: antibacterial, antifungal, antioxidant, and enzyme inhibition. So you can see different bacterial assays. Like I have talked about arbor-weaver fisheries for toxicity. You have PES for estrogen activity, EU, different bacteria for different activity. We have DBPS activity for radical scavenging and antioxidant activity, which is majorly used by all the pharma companies for the antioxidant activity level. We have Hill's reaction herbicides, tyrose for reduced melamine skin aging, alpha and beta glucose for treatment of diabetes. So this type of bioassay can be done through these bacterial and enzymatic assays. Now this is an example of bioactive activities in marine sponges. So here first we apply that sample, then we develop it. As this marine sponge is very complicated, then we develop it through your gradient system, then go for photo documentation, and then go for derivatization or bioassay technique to the Vibo fisheries. Then go for hyphenation technique, that is TLC-MS. And the TLC-MS you can do HRMS, NMR or FTIR. So like this type of data can be collected through this full system. Now what we can do for method development, if we have one unknown sample of API or of herbal, so what all steps can be done? First step is the literature survey. We have to search for the possibility that if it is unknown also, then we have to search for its literature survey. With what kind of substances is that? We have to try different mobile tests. for their presence, for finding out the presence of what kind of substances there. And then we can go for the literature survey. Then second is the solubility test. We have to check that what the sample is dissolved in at what solvent. So there are 4-5 type of solvents which they can dissolve. So at what solvent it dissolved best. So that solubility study is done. Then the sample preparation technique. At uh, what level the sample is dissolved in that. So that sample preparation technique is done. And then selection of your stationary phase, of course. Then after selecting your stationary phase, it goes for mobile phase. What mobile phase you should use, what amount, what composition you should use, that all thing. Then concentration and the volume application of optimization. After mobile phase, then you have to go for the concentration. At what concentration you get the definite level of your sample. Also the volume, at what volume you should apply. Then you can go for scanning of your scanning parameter. Likewise, I had said there are 3 lamps. So you have to go for your suitable lamp by scanning, by taking spectra. Then 8 is selection of suitable derivatizing reagent. So different derivatization reagent, as I have told you, is there. So you have to select from that, and from other detection mode also you can select. So this type of important steps are there for method development. Now you have important parameters which to be done for validation. First is the specificity study. So the specificity study is done for the proof of that which solvent or what mobile phase you are using is not showing any resonance or any uh, bands at the sample and standard level. If you are getting RF of sample 0.45, there it is not showing anything. The mobile phase and your suitable solvent. So that type of specificity study is done for your sample. Then precision intraday and intraday, comparison of two both days. Uh, then accuracy study, recovery you can do. Linearity through which you get the LOD, LOQ value, through which you get the assay of your substances. Then last you have ruggedness. You have to change certain parameters. Your mobile phase composition you can change. Your parameters such as the time of saturation you can change. Like this type you can little bit vary your timing and the ruggedness is there. So these all parameters are done for ICS guideline. So now we come for the application field. At what application field you can use the HPTLC system. You have herbal medicines, which I have shown you, food and fed, pharma, industry application, clinical application, environment, cosmetics, and forensic. So now let's start with herbal application. So here is the first example of class of compound analysis. As I have shown you 15 class of compounds earlier, the tables. So you can do all the 15 class of compounds by this HPTLC. Then you have a example of curcuma species. Here you can see there is a 3 band present of curcuma species. You can see the 4th band also, which is of C. aromatica xanthorrhiza, which is an impurity, which is an adulterant, you can say. So if the adulterant is 10%, then it shows a minimum amount of that band. If the adulteration is 100%, then you can see that C. longa 3 bands, major 3 bands are not present. So you can detect like this type of adulterant in a curcuma species. Now there is a limit test for all the herbals, for all the medicines, as well as for all the herbal products, as well as for the pharma products. There are limit tests. That 5 mg of your one tablet should contain 5 mg of your paracetamol or 5 mg of your routine flavored ones. We can say. So like this type of limit test can be done through the software itself. You can apply this standard and the sample and then compare its presence through the standard with the help of the chromatogram generated. So this type of limit test can be done. Here it is done for routine in ginkgo biloba. Then there is a fingerprinting of detection of daru haldi berberine sample. Here main berberine standard is there and the samples are there. The images are taken at 254 R wide and 366 nanometers. Then you have a sample at then you have an example of vidafenoid, vidalinoid, and vidaparin in ashwagandha sample. These four standards are given the presence detected in ashwagandha sample. Then you have identification of nimesulide and diclofenac in Ayurvedic tablets. You can find out the presence of these two in Ayurvedic tablets. You have an example of pesticide residue in grapes. Here the pesticide carbamide is detected in the given sample of grapes. Then you have an example of holy basin in tulsi plant, which is done for after getting USB chapter 203. So rosmarinic acid is the standard which is carried out in the holy basin, 2-3 different species of the grape. Then you have example of steroids in herbal formulation. So the 5 type of steroids are getting present in the herbal formulation. This is an example of that with spectra. So this is example of adulteration of in corn oil and olive oil. So olive oil is usually adulterated with corn oil. So here, when tried in GC, it has not given any extra peak of that adulterant. But when tried with HPLC, it has given the extra peak of that adulteration, which is shown here. You have an example of alkaloid presence in Arathoda vasica plants. So here you can see drag and drop reagent is used for the presence of orange band. Also, I have told you that you can compare in one plate also you can compare batch wise, that is done in 1 year or month also in the HPTLC system. So here is an example of stability study of the drug which is done at a different year. Also in 2008, then January 2009, February, March, April, May, like this different months it is done. So here 4 formulations: curcuminoid, gallic acid, boswellia acid, and generoid. These are shown the presence. So HPTLC fingerprint is done. Here, this is the separation. This is the separation of lipid glands, phospholipids, and also fatty acids, which is done by AMD2, the gradient system. So this is the complex material. So that's why AMD2 is used. Now you have an example of food science. For food science, we are using it in carbohydrate, amino acids. We are using for nutritional level checking. We are using for adulteration checking. We are using for preservatives or dyes. So detection of papaya seed in the pepper samples, we can say. So the papaya seed and pepper sample shows similar in presence. So some of them add papaya seed for greater we can say for greater selling or something. So that's why these two seeds are getting adulterated. So that's why we have done a method. We have so here you can see the papaya marker at 0.2 RS. Whereas here you cannot see the presence in pepper seeds, black pepper seeds. Whereas here, this is the standard which we use for finding out the adultery. This is the USB chapter 202, fixed oil chapter. Here, 14 oil samples are taken for analysis, and you can see their fingerprint and compare. You can compare it. Example of toxic arginine oil in mustard oil. So, likewise, I have told black pepper and papaya seed. This one is also similar. Mustard oil and arginine oil are also similar in nature and cannot be seen, cannot be separated physically. So that's why the adulteration is done majorly. So you can see the engineering plant which is there in engineering plant which is there in arginine oil which is very dangerous for our health. So that's why we have developed this method of engineering and engineering dihydrate, and we have done MS estimation of the TLC-MS detection also. So this is example of aflatoxin. There are 4 types of aflatoxin: B1, B2, G1, G2 in food stuff. Uh, Not only in dried nuts, they are present in fruits also, crops also, in medicinal plants also, and milk also. So we can do through HPTLC, and it can be detected up till ppb levels. So different type of sugar can be detected like glucose, galactose, malactose, xylose, sucrose, lactose. So this sugar detection is very difficult as they are isomers for other systems, but for us it is very easy and it is done only in one method. Now we come to pharma application technique. This is an example of limepiride in liner 1 mg tablet. The quantification is done, the assay is done. You can see the assay results here, whereas the CV values, the assay results was at what UG level it is present, and the calibration also it can be done. Also the plate image. So not only for the identification purpose, for unknown quantification impurity, it can be done. Whereas different impurities are taken from the plate and it can be detected by TLC-MS technique. So this is an example of that. We also have a degradation profiling of C-flexin and azithromycin antibiotics, which is done for the uh, different acid, bases, oxidized heat, and photo. Different heat resistance level. So, like this type of study can also be done, degradation study, through the HPTLC system. Then we have this pre-formulation tablet dosage form, wherein you have the formulation levodopa, cardidopa, and entacapone, which is used for Parkinson. So here you can see there is 3 formulation, and it can be found out in one method only. Then you have a HPTLC method for primary and cisplatin in pharmaceutical dosage. Here you can see the presence, the chromatogram technique, and also the absorption images. This is very important aspects of pharmacy. It is content uniformity test, which can be done through HPTLC technique in 1.5 hour. 15 batches can be tested, whereas in other technique it takes more than 3 days or 4 days for 15 batches. So here you can go for one go, that is go for 15 batches in one plate, and you can compare it with 100% level the content uniformity test. Now, not only one impurity, you can detect many impurities at one time. Here you can see the example of 5 impurities. This 0.1% impurity, 0.2, 0.3, and 0.5% getting detected in the sample. So here is an example of Eurofurfin HCl in USB. Now we have completed the application aspects, the instrumentation aspects. Now we have something to share with you, that is the symposium, HPTLC symposium, which is done in every 3 year in Asian countries, and it is done by to support the HPTLC papers. So every year, this HPTLC symposium is done by CANAC for HPTLC users. So in 2017, Vandana Gaude, ma'am, got Euro 2000 scholarship in Berlin Symposium. She got a prize of most promising researcher for her paper. She was there from Simhada Institute of Pharmacy. Then in 2018, the symposium was for Bangkok. So Yugendra Patil madam and her research guide, Dr. Sumita Shailejan from Julia College, has won gold prize for their posters. So now Enchrome philosophy. So Enchrome doesn't want to be your analytical partner, but also want to be your uh, it is not a trader, it is not a supplier, but wants to be your guide also. So we have a tagline of technologists, not traders. So likewise, I have already shared with you that all government labs, pharma, industry, postgraduate students and teachers are trained in Enchrome. The training are of 1, 2, and 5 days. Dates are decided by mutual convenience, and certificates are issued after training. Over 5,000 scientists has been trained since 1994, and certain MOUs has been signed by the prestigious university. If you have any problem, if any researchers have any problem in their regarding their sample analysis, regarding their samples, you can always get back to us at hptlc@encom.in, and this is our WhatsApp number. So you can subscribe our Encom YouTube channel for further videos, for further clarification of your samples, or clarify if you are using our instrument, so you can get a guideline, get a tutorial of all the steps done. So Encrom is always offering free training to PG teachers, PG students, government lab employees, PhD scholars. You can always contact us at lab@encrom.in, and also hptlc@encrom.in. So thank you to be patient, to be so over to you, ma'am. Hello. Rashmi ma'am. Yeah.
Yes, ma'am. Yes. Can I hear you?
Yes, yes.
Yes. Can you hear me? Yes, ma'am. Okay. Thank you, ma'am, for your informative talk on standardization of herbal drugs. Ma'am has very well explained how HPTLC can be a great tool for identification of compounds, how simple, fast, and reliable it is. Also, she has focused on sample preparation and modules of sample application. Thank you, madam, for the wonderful videos of auto samplers. She has very well explained hyphenated techniques, TLC-MS, and fingerprinting with different examples. Thank you very much for this informative talk, ma'am. It was a great session.
Yes, actually we are having demo session also, ma'am.
Yes, ma'am.
So
Yes,
can we go forward? You
uh,
will introduce Amit, na?
yes, ma'am. I will
So
introduce
I will
Amit sir.
mute myself.
Okay, ma'am. Ms. Neha Singh is joined by her colleague from Ankrom, India, and the members are Mr. Amit Palande, who will give a live demonstration of instruments from Ankrom lab. To share with you in brief about him, he has served for 5 years in Microchem Silicon Food Testing Laboratory. Thereafter, he has associated as a chemist in Weight Chemical Analysis Department for 3 years and followed by 2 years in technical project in Coca-Cola. He has rich experience of handling sophisticated analytical instruments like UV spectrophotometer, Carl Fisher instrument, degasser, carbonation instrument, soft drink analyzer, refractometer, titrosampler, and pH meter. Without further delay, I request Mr. Amit Palande to please go ahead with the live demonstration which we are eagerly waiting for. Over to you, Mr. Palande.
Thank you so much, madam, for a wonderful introduction. Mm, Pratik. Okay. So I'm audible? I'm audible?
Yes, sir, you are audible.
Okay, fine. So myself, Amit Palande. I'm working as an application chemist in Ancrom Enterprises Lab. So my dear colleague Sneha already explained about the HPTLC. So basically, she already told each and every information about the HPTLC. It is the updated version of the TLC. So here you can see this is our training session area where we get all the modules of HPTLC. So here one by one, I will show you, give you one short demo of the each and every modules. So first here you can see ATS4. For the application, we for in the earlier time we are doing it at a manually by using our capillaries and all. But now it is updated version of TLC to HPTLC. So for that you can use the two instruments for application. One is the ATS4 and second one is the Lenomat 5. So as the name suggests, it is ATS4 means automatic TLC sampler. It is fully automated. It is controlled by the software. Here you can see the vial tray where you have to prepare your samples and fill it in the vials and kept here. Then this is the plate stage where you have to mount your plate like this. Then here is the syringe which you will use for the application. The syringe capacity of this is a 25 microliters, and it will after giving the command from software, it will come here and whatever samples or standard you prepared in the vial, and as per the instructed in the software, it will take the sample in the syringe and it will come here and it will apply on your plate. The syringe needle will not touch the surface of the plate because it is on the spray on technique by using the air or the nitrogen gas. So because of that, the silica of the your plate will not disturb. Then here you can see the two bottles. One is for the discard and one is for the rinsing. So for rinsing, it will containing methanol or acetone mixture, and whatever discard will come into this bottle. After the application, you will go for the development part. So for development part, we having the three instruments. One is the ADC2, second one is the TTC chambers, and third one is the AMD, which is automated multiple development. Now here you can see the ADC2, which is automatic developing chamber. Now for the here you require the 35 ml of the mobile phase, 10 ml for the development, and 25 ml for the saturation. Now the USP of this instrument is that it is humidity control, which give the reproducible data. Suppose आप आज एक प्लेट कर रहे हो, आप 2 दिन बाद एक प्लेट करोगे, या आज आप मुंबई में प्लेट कर रहे हो, आपका दूसरा लैब अगर दिल्ली में, सो ये क्या करेगा, आपको reproducible results देगा. So here you can see one jar. So a jar containing the solution, different solution. Now it is filled with the magnesium hexahydrate solution, which will give the 33% of the humidity. Here you have to mount your plate Now already the development is going on. Now here you can see one plate is there, and in the back side, there is the saturation paper. Here you can see the red light is blinking, which is the sensor. So it is automated monitoring the solvent front. So you don't have to stand and you have to wait till the your mobile face will come to your solvent front. So after the automatically it will reach to your solvent front. Automatically it will take plate out in the chamber and automatically it will dry. Then after the development, we will go for the documentation part. Whatever analysis we did, so we have to do documentation. So for the documentation, this TLC visualizer we will use. Now here you can see, here the high dynamic range CCD industrial camera is fitted there, which gives the three photos of in the three illumination mode. First one is the 366 fluorescence, second one is the white light, and the third one is the 254 for the UV light. Now here you can see, this is the plate alignment guard. By using this you can take photos in different dimension, as the plate comes in the 20 by 20 size. But if you are using the 20 by 10, so by using this you can arrange that alignment and you can take photos. Here you can see the white light, and this one is comes from the whenever you are using the glass plate, that time you have to use this light. This is the reflection and transmittance light, and this one is for the glass plate reflection and transmittance, and this light we will use for the aluminum plate. I will show you. See, I think Derivatization. See, now I having the 20 by 10 plates. So I'm arranging the alignment, and I'll keep plate here, and I will show you how the images will look like. Now see, this is the 254, which is UV. This one is the white light, and this one is the 366. So these the three types of the photos you will get by using this TLC visualizer. And if you having this TLC visualizer, it will give the uh, plate comparison. Means suppose you are doing the one plate today, after that day after tomorrow, or after 1 week. So you can compare that plate also. You can label that plate also, and these images will automatically attach to your report. Now this one is the scanner. This is the CAMAC TLC scanner. It is the heart of the HPTLC. It will give the scanning and spectrum data. It containing the scanning from 190 to 900 nanometer range. It consisting the three lamps, tungsten, mercury, and deuterium. Here you can see, like this, you have to mount your plate. And you have to give command from the software. Then whatever the requirement of your scanning range, it will scan your plate and it will give the scanning data. And for the further confirmation, you can take the spectrum also. And if you have to do any quantification, so you can do the quantification also by plotting the calibration graph. Pro. Now, as I told you, for the application, we have the two instruments. One is for the ATS and second one is the Lenomat 5. The difference between the ATS4 and Lenomat 5 is what? First one is the fully automated and this one is the semi-automated. Both are doing the same work, which is application. Just a 1 minute. So here you can see this syringe we have to use for the application. Now the ATS4 syringe is the 25 microliters. Here in the Linomat 5 you can use the two types of syringe. One is the 100 microliter and second one is the 500 microliters. So here you have to mount your plate and you have to manually fill your syringe and rinse and place here, and you have to enter. So automatically it will come and it will start the application here. Now this one is the AMD2. Sorry. AMD2, it is an automated multiple development. Here you can see it works on the vacuum pump. Here is a small chamber. Here you can do a gradient type of development. This is the chamber, so no need of saturation because it works on the vacuum. Here you have to mount your plate. It consisting the 5 different bottles with different reagent for your development, from polarity wise, from non-polar to polar or polar to non-polar. It is mostly used in the R&D purposes to develop your mobile phase. Now here you can see the derivatizer. Now this is the patent technique of the CAMAC. It requires only the 2 ml of the reagent for the 20 by 10 plate and for the 4 ml for the 20 by 20 plate. It works on the piezoelectric effect. I will show you. This is the nozzle. Here you have to mount your nozzle like this, and whatever solvent you have for your derivatization, so you have to fill here, close that, and from using this level, these are the level, according to your viscosity of the solvent you have to choose and just press this button, so it will started the spraying. Here inside here you have to place your plate, and it will the whatever the solvent you have derivatizing reagent, it will spray on your plate. It is eco-friendly because all the harmful fumes are collected in the bottles which containing the ethanol and water solution in the backside of this bottle. Now this one is used for derivatization, and second one is you can use for derivatization is the chromatograph immersion devices. So here you have to mount your plate. This is the chamber where you have to fill your reagent. Now here required almost 180 to 200 ml of the reagent for derivatization, and that derivatizer requires only 2 ml and uh, 4 ml for the derivatization. So if here you will mount your plate and just click here, it will automatically go and dip your plate and automatically come out. So it is a speed and time controlled immersion device. Now this one is the TTC chambers we can use for the development. It is well means good quality of glass used for the making of this chamber. In the end you can see there is a trough which is divided into two parts, the mobile phase. One is for the gas modification and one is for your development. So we have the different dimensions TTC chamber. This one is the 20 by 10 chamber. This one is the 10 by 10 chamber. Here you can see the saturation is going on. This side you have to place the Wattman filter paper, and other side you have to place your plate for development. Okay. So now here, this is the TLC-MS interface. First of all, this is the HPTLC hyphenation technique. So this is the pump, LC pump you required for this. Now the outlet of this pump is joined. Hello. Outlet of this pump is connected to your interface, and outlet of this interface is connected to your LC or MS for finding the mass to charge ratio. So what happened, here you have to mount your plate here, and by using this laser light, whatever the band you want to send to MS for finding the mass to charge ratio. So here you will place the plate, and by using this piston, you will lower the head. Huh? Okay. So it will lower the head, and it will and then it will passes to the MS for finding the mass to charge ratio. So after the MS analysis, you can see here how it is extracted from the plate. Whatever the required band you will send to the MS. So this type of the extraction will done on the plate. Now all the modules I have shown you, which is controlled by the one software, which is the VisionCAD 3.0. So I will show you one plate of my analysis file, which will give you idea how the works or analysis is going on by using this VisionCAD. So I will share my screen. First of all, this is the software, which is VisionCAD. After login in the VisionCAD software,
Mr. Amit, please share entire screen.
okay, just a 1 minute.
If it is something to be played, no, it doesn't seem otherwise. Thank you.
Yeah, now it is visible. Hello. Sneha, it is visible, my screen?
Yeah, now it is visible, Amit. Go ahead.
Okay. Yeah, thank you. So after login in the VisionCAD software, for login you have to one login ID and password. After you login, this window will open. So from this, you have to select the modules which required for your analysis. Now I will show you one file which containing the caffeine in green tea. Suppose you're having a green tea, and you have to find out the caffeine from that green tea. So how can you do that analysis? So for that, I will show you one file of caffeine in green tea. So here you can see first 4 are different parts containing the different modules. First one is for the application. So for application, I show you the ATS4, which is fully automated, and second one is the semi automated Linomat 5. So from that you have to select one applicator. After the applicator, for development you can select from these three, ADC2, which is fully automated, then AMD2, it is also automated, but it's cover the automated multiple development, and and third one is the chamber, which is manual technique, but mostly we can do analysis by using this TTC chambers also. Then for fourth one is third one is for derivatization. So all if all you know, the derivatization means what? To sometimes what happens after the development, we cannot see any separation or bands in the UV or 366 or in the white light. So for that, if you require the derivatization process for giving the chromophore to that bands. So for that you can use the derivatization derivatizer, which I already shown you, which contain only 2 ml and 4 ml of the reagent, which will take less amount of the chemical. Then immersion device, and third one is the spraying technique. And for detection you can take the visualizer for photo documentation and scanner for your scanning and spectrum analysis. So now after finishing step, this will create your analysis file. Here you have to fill each and every information about your sample and standard. So I will do the quantification analysis. So for first, from 1 to 7 I put it the caffeine standard, and from 8 to 13 I put it the green tea samples. So I prepared the caffeine is 1 mg per 1 ml and green tea 100 mg per 1 ml. Both are prepared in the methanol solvent. So here you have to give the volumes, how much microliters you have to apply. So I put it the 1 2 3 4 5 6 7 microliters, and from here I put it the samples triplicate in a 4 microliters and 5 microliters. Yeah, I selected the ATS4. That's why here I have to give the positioning, which I showed you that vial tray. So it containing the 66 vials space places. So in a one line you can put 11 samples, A, B, C, D, E, F, G, just like that. So I put it in the A1 is the standard caffeine, and A2 in the sample. So here I will do the reference, because caffeine is my standard, and as it is sample is, I will keep as it is like. Then second one is the visualizer. So I told you there you can take the photos R white, RT white, R254 and 366. If you having the aluminum backing plate, so that time you have to take the R white, R254 and 366. But if you having the glass plate, that time you have to select the RT. RT means the reflection and transmittance. And when you're having the only aluminum backing plate, that time you have to select the only R white, which is the reflection white light. So here I use the aluminum plate. That's why I selected the R white. R25 means UV, and the 366 is the fluorescence. Then I use the ATS for the application. Here is the TTC chambers I took for development part. So for the quantification, I took the 20 by 10 size. So I selected the tank size is a 20 by 10. Here is my mobile phase, toluene and acetone. Then after the development, here you can see this is my plain plate, clean plate images. Before analysis, I took the photos. Then after the development, here you can see I got it the separation. So this is the white light images. This one is the UV. So here you can see by using, if you're having the TLC visualizer, so you can label it. So here I put click on label. So all the standard and sample are named, just like the from first 7 are the caffeines and others are the my green tea sample. Now here you can see from 1 to 7 are my caffeine standard, and here you can see on the same RF another band is present is also in the sample. So that means the caffeine is also present in the sample also, because at 0.22 RF it is also coming 0.2122 RF also. By using this you can spot amplify. After the development, suppose you are getting this type of the separation, so you can just spot amplify by using this. So it will dark that color, so easily visible. You can use the RF tip like this. You have to click here, and suppose I have to click here, it will automatically give the RF values. You can put a RF tool measurement. Now I have to quantify that. So what will I do? I will scan this plate. So for scanning, I use the scanner. So in the scanner, what I did, I selected the single lambda optimization, whatever the required parameters I filled, slit size, everything. Now slit size is what, that the scanner is containing the photo multiplier tube. So after I selecting the lamp, we have to select the slit size from which it will goes the light and it will scan. So always we apply by according to the USP method 8 mm of the band. So from of the 8 mm of that, 80% of that 8 mm band is the 6 into 0.45 size. So I selected the 6 into 0.45 of the slit size. Here I have to choose the lamp which I will use for the scanning. I already told you the scanner having the three lamps: deuterium for the UV, tungsten for the white light, and mercury for the fluorescence. Now after the development, I see there my caffeine standard is visible in the UV light, so I selected the deuterium lamp for my scanning at a 254 nanometer wavelength. So I scan my plate. So this type of the pics I got it. So from that I selected the 5 standard for plotting my calibration graph, and I took it the one sample, and by using the substance assignment, I assign all the standard and sample, and I plot the calibration graph. So here you can see which is the regression mode of linear 2. This type of the graph you will get. CV is the correlation coefficient is 1.09 CV. R is the 0.99. You can do polynomial curve also, and in the result you will get the value. So now here you can see 1.421 milligram of the caffeine is present in 100 gram of the green tea. So like this you can do your analysis if you have qualitative quantitative analysis. So by using the HPTLC you can do analysis. After the completion you will get the complete report from here. You just have to click here report. We generated the PDF file of your report. So generating the PDF report. Now see here, each and every information about your analysis, from who did the analysis, at what time, what date, what sample you are doing, what sample standard you use, how much volume, each and every analysis for plate layout, how what dimension you plate take, what are the reagent you used, what is your mobile phase, everything with your photos. Here you can see directly photos will add it to your report. Spectrum data, scanning data, everything will be recorded in your report, by uh, even calibration graph also, and the final result also. So everything will you get in this report. So I think that's it from my side. Sneha, I will stop sharing my screen.
Yes, thank you, Amit.
Yeah.
Now
If you
can we take some questions?
yeah, they can ask.
Yes. Now can we take some question, Rashmi ma'am?
Yes, ma'am, we can take a few questions. The Vishwajit sir is also going to join for a Q&A
Yes,
session, right?
yes, yes,
Yes, yes,
So I
yes.
will introduce him first, then we will move on to Q&A session, right?
yes, yes.
Yes, ma'am.
Okay, ma'am. Thank you. Now we will move on to Q&A session. This question and answer session team comprises of Mr. Vishwajit. It is comprises of Mr. Vishwajit Kale, who is working as an application specialist in Anchrome. He brings with him his immense experience for developing new HPTLC methods in academia, pharma, foods and forensic, herbal and organic sector. So we will take few questions. First question we have is from Priya Gupta. She is asking, can we use methanol as a solvent for any herbal drug regardless of its nature?
Yes, we can use methanol always because it is showing mid-polar. It is a mid-polar solvent. So that's why we use mainly methanol. But any other also you can use. Uh, the thing is only the thing is the substance should be fully dissolved and should not show any saturation or any other degradation. That's it from my side. Vishwajit, you want to add something in this?
Uh, Yes, you rightly said, Sneha. As per solubility studies, we have to go for solubility first, in which solvent it is soluble. Means not whole of your sample, the analyte of concerns, whether it will be one, two, or three, or more than that. Analyte of concern, you have to check the solubilities. For that, first of all, after proper sample preparation and referencing, you can proceed for solubility studies. Uh, and as per solubility of your analyte of concern, you can select suitable solvent. Not required always methanol. You can select chloroform, DCM for oils, and toluene also, hexane also for oils and non-polar components you can use. Yes.
Yes, thank you, sir, for your answer. Next question we have is from Siddhi Bhosle. She is asking again about the solvent. Why is methanol and ethanol mainly used for chromatographic technique?
So that only I had answered you.
Yes.
It is because that is mid-polar, and mid-polar is mainly used for non-polar also, for polar substances also. So the both are dissolved in this mid-polar substances. So that's why we use mainly methanol and ethanol. But you can always use other substances like rightly said by Vishwajit, DCM, hexane for oily matters, like depend upon your samples always. So that's
Yes. Yes. Thank you, madam.
Yes, ma'am. In this regard, most of the time in phytopharmaceuticals and botanical origin material, we are making formulations for oral injection and internal uses. And in that, we are concerned with hydroalcoholic extracts most of the time, or ethanolic or water aqueous based extract. So methanol and ethanol are showing good properties and
good.
good solubilities. So methanol is having resemblance with ethanol. Therefore, we are using methanol mostly. But I suggest in phytopharmaceuticals use ethanol as a solvent, because final formulation will be in ethanol or in water or in mixture of both. Yeah.
Okay, okay. Thank you, sir, for your answer. Next question we have is from Prachiti Aire. She is asking for herbal drug standardization using HPTLC, which reference material, that is book, pharmacopoeia or manual, we can use.
The pharmacopoeia I have told USB 203, 202 you can use. For the phytochemicals drug, plant drug analysis book is there. We also refer that only for making that tables of class of compounds and all. So you can also refer to that plant and drug book by Wagoner. And also what else he has told? Manual. So we are using HPTLC guide, from that only you can use. Or if you need from us HPTLC guide, you can just mail us to lab@encom.in that you need that guide, and we can mail you for
Okay.
your
Thank you,
research
ma'am.
book.
Okay. Thank you, ma'am. Next question we have is from Anita Aire. She's asking, is it always necessary to saturate the chamber for a predefined time, or we can monitor the same by inserting a filter paper?
Amit, you want to answer this?
Yeah, yes, ma'am. Because in the USP, you can they are doing the all the analysis, and after they did, um, you can say the after R&D, they are stated that you require the 20 minutes of the saturation to getting the good separation, and it will give the good RF values also. Because suppose now I am doing the saturation, I'm doing the analysis in the TTC chamber, so it is the open chamber. It also consisting the humidity and air already in it. So after you are pouring your mobile phone in that and closing with your closing the TTC chamber with the lid, so it can replace that the humidity and air with your mobile face, and it will give the good separation and good optimization for your analysis. That's it.
So, as Amit rightly told, that when we are putting our mobile face in the chamber, it requires certain time for saturation and for attain the full humidity of that chamber. So that's why it is 20 minutes. But it can change, or also it can change up to 1 hour depending upon your monograph, what your monograph says, or what your method says, and also depending upon your sample nature also. If it is very polar, so it requires more time for saturation. If it is less polar, some of the monograph says it requires only 10 minutes. So it always depend upon your sample. But if you are going for unknown, USB has told for 20 minutes saturation.
Okay, thank you, ma'am. I would like to share a few comments for your
Yes.
presentation and such an informative session. Our VS College HOD for QA department, for Quality Assurance department, Dr. Rajashri Hirlekar, she is expressing her thanks to Ancrom for providing training to our students and staff at their labs. So,
Thank you.
thank you, ma'am, for your comment and for your sessions, Miss Neha, ma'am. Next, there is one more comment from Dr. Anita Aire. Uh, sh- she is expressing her thanks. That is, she is telling excellent demonstration by Ancrom Labs. Thanks a lot for extending your support and knowledge to us. As always, we at VS College of Pharmacy are very grateful to entire Ancrom team.
Thank you.
Thank you so much.
Ma'am, we have one more question. Can we take it now?
Yeah.
Yes, yes.
Okay. Question is from Kajal Bajaj. How tailing effect can be avoided in TLC?
Vishwajit, you want to answer?
Yeah, tailing effect. Am I
Yes,
audible?
yes,
Yes,
Hello.
yes.
yes.
Yeah. After scanning, if we get tailing in peak, means peak response generated, in that case, we can say the separation of band is not proper and band is diffused throughout the plate and showing us a vast difference in starting RF value and end RF value. So in that case, the generated peak will show you tailing effect or fronting effect and unsymmetrical peak. To avoid that, I request you to use a less ratio of water in your mobile face. And more polar mobile faces will give you most of the time tailing effect. So to avoid that, you can develop a mobile face in such a way that your analyte of concern will come at nearly lower RF value at the lower half of the plate, so that it will not get diffused throughout the plate during separation and not show us a tailing effect. And there are many other factors are there in tailing effects, means exactly which kind of samples you are handling and which kind of analytes you are analyzing and which kind of mobile phase components you are using. It completely depend on that every solvent and every chemical. So the answer is very vast, but if you avoid using more polar solvent systems and if you give more time to diffuse in plate, more time to analyze to diffuse in plate, it will give you telling effect.
Okay.
Yeah.
Thank you very much, sir, for your answer. Now, we have one more question. It is by Apurva More. If a drug in standard has 3 spots in TLC and 1 spot is missing in formulations every time, what can be interfered from this observation? What can be inferred?
Vishwajit?
Yes. If a drug in a standard has 3 spots, means there will be 3 different spots in standard and only 2 standards in formulation. So you have to check first specificity of your method. Means whether that third peak is in standard is coming out because of your solvent you have used for dissolution of that standard, or because of any instability in standard. But definitely you should have to know about your standard, because standard is most of the time known for us. And after application, whether your standard is giving a single spot or double spot, that you should have to know. And if you are completely okay, and if you completely know that yes, my sample, my standard is always giving 3 spots, and in our formulation we are getting only 2 spots, so in that case you can say that standard is not present, that third spot is not present in our formulation, and you can make conclusions. But specificity studies and after proper method validation only you can make conclusions that third spots in standard will be because of lower grade of solvents also, most of the time, or we can say any impurity generated during the storage of that prepared standard. Yeah.
And she is doing TLC actually. So in spotting also, the spots get emerged sometimes, as I have
Yeah.
shown in my second slide. So the spots are not that much good in resolution as in band. So she should try HPTLC rather than TLC first and then see. And also it can be the chance that in formulation it is getting mixed, the two drugs getting mixed. That can also be the chance. That's it.
Okay. Ma'am, there is one question from Saili Dalvi. She's asking, how can we approach you for the training program?
So the training now as in we have COVID-19 situation, now it is closed, but you can mail us with whole staff names at lab@ncom.in, and we will suggest you the suitable dates for training after once COVID-19 situation is fully resolved, and then you can come for the training.
Okay. Thank you, ma'am. That's all for the question and answer sessions, ma'am. Thank you very much. Thank you, sir.
Thank you, ma'am.
Thank you, VS, for giving us the opportunity to be a resource person, also to share our knowledge to all the students, to the upcoming brains, I can say. So, thank you to all the team of VES. You are doing a good job. Thank you, and be safe to all the participants also.
Thank you, ma'am. I would like to request all the participants to fill the feedback form and share it with us. Your feedback is very much valuable to us. And also, please visit our YouTube channel and subscribe it for constant updates on upcoming events organized by VES College of Pharmacy. Stay tuned for our next session, which is there on tomorrow sharp at 2 p.m. So we will live at 2 p.m. Thank you very much.